Welcome back everyone, this is Simon. I am the stupid astronomer because I do the stupid things so you don't have to. And welcome to this tutorial, which is going to be about the moon. And we are actually going to go from the stacking part all the way through to the processing. I've already pre-recorded some footage of the moon, which are essentially these two files here. No idea why this folder's here, but let's ignore it. And what we're going to do is we're going to end up stitching the two pictures together to form a complete image of the moon. So I've already gone ahead and captured the video files. You can download them. They're kind of a little bit off the big side, but you know, we want to work with as much data as possible. So the programs we're going to be using today is going to be Autostakkert, PEC, bit of a mouthful, and of course trusted Photoshop. So let's get started. We want to basically stack these frames, and I'm using a program called Autostakkert, which again you can download for free. Link is in the description somewhere, on the Patreon page somewhere. I'm sure it's hiding somewhere. So first of all, we're going to go check out our footage. And here we have our moon. So the thing at the top here where it says frames, this allows you to basically go through each of the individual frames. In this particular case, I only captured 100 frames because when you're typically doing the moon, that's all you really need. You don't need a lot of data. And of course, there's the zoom function here if we want to zoom in into the moon a bit more and just basically just check through to make sure everything looks good. So the next thing we're going to look at is the visualization. These are the anchor points. So we can actually set it to draw the anchor points or not, because we may or may not want to see them. I will go into that in a little bit more information. The scaling fits and SER file, kind of ignore all of that, but basically this gives you the quality of how good or bad an image is going to be. So you can turn it up to, I think it's as high as this one goes, is going to be 24-bit in this particular case. Typically this is not suitable for lower bit scale images. So if you caught your video files in say AVI format and they're only 8-bit, I would strongly suggest just turning this back down and just setting it to automatic and let it just determine itself. So in this particular case we shot this in 16-bit and it's already detected that, and that's good to go. Brightness. This can be kind of useful. Now remember, this does not alter any of the data. If you find your image a little dark and you're trying to work with it and you can't quite see what's going on, you can always increase the brightness so we can see what we're doing. So in this particular case, we will increase the brightness just so you guys can see what is going on. In my case, I'm only going to go for a 2 times the brightness so I can see more or less of the surface details. And the last part here is exporting the frames. If you want to export them out in any particular format, or if you just want to try and analyze one particular frame, you can go ahead and do that from here. Now going into the main window, there are plenty of settings here that will probably lead to nothing more than confusion. And since we're actually shooting with monochrome, because this is actually a monochrome image, typically you would set that here. If you knew your camera had a specific Bayer matrix pattern, you can also preset it here. Typically I just set it to auto detect and allow the program to figure it out. Memory usage, you could do buffering or no buffering. Typically leave it on buffering. You kind of want to load as much of the data into memory to speed everything up. If you've got a low-end laptop, like you've only got 4 gigs of RAM or less, then I would strongly suggest that you turn off the buffering. It'll help with the performance, but it should not be that big of a problem. So for now, just leave the buffering on. In the advanced section, generally speaking, probably best not to mess around with any of these things unless you're really, really confident. Some of the settings that you will see in here may be applicable depending on your situation. Again, you can kind of experiment with some of these settings. I leave these alone because I have no real need or use for these parts as of this particular tutorial. Image calibration. Depending on how you shot your image, there are different types of settings that actually help with different problems. For example, row noise correction, where you get strange horizontal banding. That's typical if you use the 174, so it's like the ASI 174, the QHY equivalent, or any other sensor for that matter that has the IMX 174. They leave this banding on the actual image, and this can actually help reduce those lines. Master dark and master flat, if you're unfamiliar with this, these are basically calibration frames. If you're doing a lot of long exposures, for example, you would probably want to use some kind of a master dark calibration file that would subtract some of the noise out of this. Because we were shooting the moon, which is quite a bright object, we will not need to worry about those types of problems. Master flat files, on the other hand, can be quite critical, especially if you have a scope that has like dust motes on it or some kind of a blemish or something along those lines. You can actually shoot a master flat to get rid of some of these problems. Again, when shooting with something like the moon, flats and darks don't tend to actually be that necessary because we're dealing with a lot of light, and in all honesty, a lot of the dust that would be present on the camera lens or on your telescope lens will not really manifest itself unless you were shooting something that was incredibly dim and dark. And of course, load dead pixel map. If you have a camera that has a couple of dead pixels or hot pixels or something along those lines, you can load a map of this to get rid of these problems. You would typically call this a bias frame, and again, in this case, I'm not too particularly worried about it, so I can just simply ignore this. If you find the need that you want to create a master frame, what that basically does is you're looking through for the best individual shot, and what you're trying to do is create a calibration and a master frame driven from this, where this particular program, Autostakkert, will use that frame as a reference. So now that I've kind of gone through some of these settings, let's have a look at the actual main part of the window. This is the actual image stabilization part. Depending on what we're working on, we would select either a planet or a surface. Now in this particular case, even though the moon is not really classified as a planet per se, but it is a circular object, and this program actually does really good to detect if something is actually a surface or a planet. Now how you would tell the difference between the two is if there is no circular object, kind of like this, how the moon is cut off at the bottom here, we would actually be better using the surface as opposed to the planet tracking, because you'll see that it's going to try and figure out what's going on, and it almost knows that the curve or the bottom part of the moon is missing and tries to accommodate for that. In this particular case, we are going to use surface because that's what this actually is. We're going to be tracking off of one of the surface details. There are different other settings here: improved tracking, expand and cropped. It kind of depends on how good or bad your actual data actually is and how much movement there is. And considering that this barely moves and there's very, very little drift, especially because I was actually using a tracking mount, I don't actually need to do improved tracking. But if you have something that's like you were on a Dobsonian and you were trying to record off of something like that, then you would use improved tracking to help stabilize the image. The quality estimator, I would typically leave this alone as the default setting is usually pretty good. Noise robustness is, as it analyzes the frame, it kind of reads how much noise is coming off each actual frame, and it'll try and make sense of that. This typically is only applicable if you've got something very, very small like a planet, where it only probably occupies, say, 50 by 50 pixels. It doesn't want to see too much noise and scintillation going on, so what you would have to do is increase the noise robustness for it to be able to track better. So you don't want to like track a piece of noise and then that pixel starts jumping around all over the place and it starts tracking that. So that's what this essentially does. It's very, very experimental in the sense of how you would use it, considering the data that you might obtain may or may not be as noisy versus one from the other. The type of quality estimation is based upon either the anchor points or the actual frame as a whole. Depending on what the subject is, it varies depending on what you're doing. In this case, we are going to look at the entire frame, so I'm going to select global. And then the button here will do the analysis. There will be a double stack reference. That's basically, it'll try to run the stack twice to make sure that it's actually accurate. So if there's any variations or offsets, it'll correct for that. Auto size based upon quality. What this basically does is it picks out the best frames based upon the quality, and you can kind of tell it how many to go through. Typically, just set it to automatic because we're not doing anything strenuous. Now, the other part here is, we're going to ignore the center part because that's obviously the status window. This actually determines what types of files we are going to save. So we've got a choice of TIFF files, PNG, or FITs. If you are working with a lot of scientific data, I would recommend that you always use FITs files. Otherwise, if you're planning to go back into Photoshop and you're going to process everything between the two, it's either TIFF or PNG. I prefer to use TIFF because it tends to be an uncompressed file format. Number of frames to stack or frames percentage to stack. Basically what that means here is I can set a number which tells Autostakkert how many frames out of these frames that I currently have, which is 100, that we are going to stack together. I will go into that in just a moment because when we actually do the analysis part, it will determine or tell us what we can and can't get away with. You get this other option here called Sharpen, RGB Align, and Save in Folder. Let's have a look at the Sharpen thing first. Since we're going to go and process this image, we actually want to leave this unchecked. What this does, it'll apply a sharpening filter to the final image that is saved out. In this case, I don't want it to do that because we are planning to process it, so I do not want to add any type of filter in there that would change the quality of this particular image. Save in folders, exactly as it says. It'll basically save it in the folder the actual files were contained in. You will see a folder being created in just a moment when we actually process the actual images and stack them. Stacking name options is kind of a little bit tricky and a little bit convoluted in some ways, but it doesn't take that long to get used to. You can actually set all the different parameters in here and it'll name all the files according to what you have done. So I just leave this alone, just load the defaults into it and you should be pretty much good to go. If there's any reason why you need to change anything, go ahead and change it in here. Next thing we're going to look at is drizzle and resampling. Typically you would only use drizzle and resampling if you feel that your images are undersampled or the actual image is kind of small and you kind of just want to bump up the actual final image size. This is already a big file, so these are things that we're not going to look into. I will have other tutorials that require drizzling, but in this particular case we're just going to ignore it and we're just going to carry on with doing the stack. So now that I've given you a quick run through of what some of these functions are, let's actually try and figure out how to stack. So the first thing here is you're going to notice that there is a image stabilization anchor, and I can set its position by simply holding down the control key and left clicking anywhere on the picture, and that will set the anchor point. Now what the anchor point actually is looking within this frame and checking every single frame to see if anything moves. If it moves, it'll nudge the frame so it all lines up when they do the final part of the stacking. I like to find a nice bright surface feature, so this has got something good to track against, preferably high contrast. So we've got multiple things that we can work off of. We can work off of this crater here or even this crater here, and I'm probably going to favor this one here because it's a good area to look at. Once you've actually done that, the Analyze button is your actual next step. So we're going to click on Analyze, and what this is going to start to do is it'll start checking every single frame. What it's doing right now is it's checking the actual image one by one, and then it's going to set a reference frame. Once it's done that, it'll check through and look at the rippling. So if you've got bad seeing, you'll notice the moon rippling away and the image kind of just breaks apart every now and then. And what that part does is it tries its best to kind of recombine that together and reform the image to be able to give you an accurate figure. So now that we've got that, we now have this quality graph here that tells us how good or bad our frames are. The part that I'm looking at is this line here that tells me how good the quality is. So more than 50% of all the frames are above 50% in terms of the quality. So this line here over time tells me how much quality or how good of a quality each actual individual frame is. So when I look at this graph here, I can actually see how good my frames are. And the idea here is we do not want to stack bad frames, because it seems that we've got 1, 2, possibly 3 areas where the frames are just not very good, and we can kind of scrub through and just preview them to see what's going on. And you can almost see where it's almost seeing conditions has caused a big ripple here, and it's considered that as a bad frame. So that's the great thing about Autostakkert. It's going to try and determine what is a good frame and what isn't. But I can see here that I have at least 20% of all my frames are above the 75% mark. So that's what I'm probably going to go for, is the 20%. I can actually dial individual numbers into here, but obviously it cannot exceed the total number of frames you currently have. But in my particular case, for this particular file, I kind of deem that 20% seems to be a good number, because if this is 25, around about here will be the 20 mark. This means that all the data in this area is probably going to be good, which basically translates to these areas up here, pretty much towards the end of the video. The next thing I need to do is set anchor points. You can actually do this manually by simply clicking on manual draw, and you just basically click around the area and just set the anchor points. But there's actual presets which actually work incredibly well. You kind of have to determine the size of the box. You don't want them too big, because what happens here is if they're too big, you end up getting these great big boxes that just simply won't be able to track very much information. You kind of want a good coverage of whatever it is that the object is tracking. So it kind of reflects the way the surface looks, and you'll notice that it kind of tries to do its best to find anchor points to actually stabilize against. So I'm going to do that again just so you can see it. We're going to select a particular number, so in this case was 200, and we can just click on Place Alignment Grid. We can actually increase the size of this if you find that you're having too many alignment points. The more alignment points that there are, the more accurate it is, but the slower this gets. So I'm going to set this to have a larger anchor point to around about 300 or so, and just simply click on Place Grid. And what this will start doing is it'll start placing my anchor points for me based upon the image. Ideally, you don't want these anchor points to be too big, but you don't want them to be too small either. Otherwise, this whole thing just takes an awful long time, and quite honestly, I don't think anybody's got the patience to wait for something so simple. Once we've actually got the anchor points selected and placed down on here, we can simply click on Stack and allow the machine, I guess, to do its thing. I'd go through the process of what this is actually doing, but I'm pretty sure you don't want to hear this, to be honest, as it's not particularly interesting. So we are going to fast forward and skip past this until we get the final image. So hold on to your socks, because this is suddenly going to go very, very quickly. It's now done its thing. In other words, it's aligned all the images, it's stacked it together, it's done what's called a map analysis and a map recombination. This is actually related to upon these alignment points. If you have more alignment points, the map analysis and the recombination is actually a little bit more accurate. I'm not too worried, because I knew the seeing conditions weren't that bad, so I'm just going to ignore it for now. And remember when we clicked on Save in Folders? Well, it's now created a folder in here that has the actual image that has been stacked, and we're just going to quickly open this up just to check it real fast. And it's done a pretty good job of stacking it, as you can see. It may look a little bit soft or a little bit rugged right now because we haven't actually processed anything. And remember, this is a monochrome image that we are dealing with. There's no color data in this whatsoever. So we're now going to minimize all of this, and we're going to open up this program here called IMPPG. Now this program is free to download. Just simply do a search on the internet for it, you'll find it. There'll also be a link inside the Patreon posting, as you will probably see just below. This program is basically a form of deconvolution. Deconvolution is a very, very popular filter used by a lot of astronomers. In fact, this particular program is probably one of the astronomers' best kept secret, and I personally like to use this program as it is quite powerful, and in some cases I find that it's actually better than using wavelets, especially on something that's so large like the moon, or even when I'm doing solar. If I was doing planets, on the other hand, something like this may not be suitable, but it kind of depends on how big the actual final image is. And considering that we were working with an original file that is actually quite horrendously big, we're not going to have any type of problems with this. So let's just open it up and start doing some of the processing. So we're going to navigate to our folder where it saved it and open this up. Now, first of all, we need to kind of shrink the window so we can actually see it, because by default it will probably just open up and you're going to get this great big black screen and you're going to go, oh, where is it? And you can slide around and just basically try and find it. Now, there is a preview window which basically cuts down on the amount of time that it takes to actually do any type of render. I'll show you that in just a moment. You can preset this to any particular size. You can just draw a small area and it'll actually start doing something. What I prefer to do is, depending on how good or bad your machine is, I like to work on a slightly larger scale. So I'm just gonna basically go into this and do a select all. And I'm okay with waiting for this because I kind of want to see the final result of the picture. It does take a little bit more time to do all the processing, but to me it's well worth the wait. So before I go into doing any of the actual settings on the filters, what I want to do is I want to affect the tone curve of the actual image and try and get that dialed in to look as good as I possibly can. When you're doing something like this, you're following the same rule of the histogram, but you'll probably notice if you're doing something like the moon, there is quite a heavy contrast between the blackness of space and the moon itself, which is represented in this area here. This part here is obviously the moon, and these are some of the highlighted areas. So it works very similar to an S-curve in Photoshop. The more you play around with this, the more this changes quite dramatically. And what I want to try and do is basically brighten up the moon so I can see some of the key details and increase some of the contrast. But what I don't want to do is start making it look too unrealistic, because we can start changing some of that stuff in Photoshop at a later point. All I'm trying to do is just get some of that contrast up so I can see the details and see the difference it makes when I apply these filters. So first things first, we're going to actually look at the deconvolution side of things. First thing to do is select the prevent ringing. What that does here is, if there are certain details on a particular surface or on the planet, or in this case the moon, you don't want strange little artifacts appearing where it's a halo, for lack of a better description. As you increase the amount of deconvolution, the chances of a halo appearing around a circular or a square object increases, and it just looks odd. So I typically try and have this selected just to try and circumvent those problems. Now, unfortunately, there is no set particular goal on this particular part of the processing. It's not a magical number. You kind of have to experiment it by pulling this slider backwards and forwards and seeing how good or bad something gets. So what I typically do is I basically set it to the absolute maximum on the scale, just to see how much of a difference that it's actually going to make, and then decide how much of this I want to scale back. So as you can see, I've just basically pumped it up to 2.6, and immediately the results is quite evident. You can see how this crater here has changed quite dramatically, and if I just do a small preview draw, we can actually see in real time how much of a difference this actually makes as I move the slider. And I can keep on doing it as much as I want to the point where the image just simply breaks apart, and obviously we don't want something like this to happen. So we're going to go back to where it was, which was 1.3 was the default, and we're going to slowly tweak it up until we get to something comfortable. Now already 2.6 to me was a little bit too much when it was the maximum setting, because we can start to see pixelation starting to occur. So let's just go for a happy medium. Let's go check out number 2, and that seems to be pretty good. You can kind of check before and after by just simply drawing somewhere else, and that seems pretty good. So let's live with that. I'm going to leave a little bit of this exposed. In fact, let's do a halfway mark. Let's do a half of the crater with and without, so we've got a good comparison. So we've set the sigma part of it. I mean, it's the same principle as sigma clipping, in case you were wondering. Now we're going to do the sharpening part. So the sigma sharpening mask here is actually determined by the pixel size and then the amount. There is a setting here called adaptive if you want to fine-tune any particular things. I typically leave this alone because it can get quite convoluted in some ways itself, no pun intended. So I tend to not play around too much with the adaptive settings unless I was trying to fine-tune something. So again, just like we did with the deconvolution filter, we're going to take the actual setting and take it all the way to the top just to see how much of an effect that it will actually make. So let's just set it to a value of 10. And then we're going to increase the amount to something quite drastic, to 5, so we can see there's been quite a difference. Now we can actually start to scale this back to something a little bit more reasonable, and as we pull this back, what we're looking for is that fine balance between when it starts to break apart and when it looks like it's actual detail. So right now we're very, very close. Now remember, the default was actually 1.3. So we're just going to bump it up from there, and I kind of feel that possibly 3 might be the magical number. Now this does look a little bit over the top, over processed, because some of these areas here are just looking way too sharp for what they need to be. So the amount that we actually apply now needs to be turned down. So we're going to set it back down to 1 for a second, and we're going to slowly increase it until we get just that right balance of where it looks real without it getting too crazy. So we're going to go back to around about the 2 mark, I think, and work our way up from there. So let's try going up to as high as 3, and that seems pretty good. So if we were to look at the 2 comparisons, you can see how soft the original part of this looked after the stacking, and then once we apply the filter, you can actually see it's done a very, very good job of actually fixing this, and we can start to get an idea of what's actually going on. So we're going to zoom back out so we can see the entire moon, and we're going to select all by clicking on edit up here and then select all, and this will start applying the entire filter to the entire image so we can preview the entire thing. Depending on how good or bad your machine is, this can take a moment or two, but once it's done, you kind of get the end result. And I'd say I'd be quite happy with this. And before we go ahead and save the image, we have to do one important thing, because remember, we are planning to stitch 2 images together to create an entire moon, which will be this one. Click on File, and we're going to click on Save Process Settings, and we're going to put it into the same folder. So we're going to put it into, it's on the desktop. So we're just going to call this one Settings Moon, so we know what it is. We'll save that. And what this does is it saves these settings, so we don't have to try and remember them or write them down. We can just simply apply the setting like as a global setting, so to speak, to the other image. So I'm going to go back into Autostakkert and open the other file, which is the bottom half of the moon, and we're going to basically do the same thing and stack everything, and then once I get to that point, I will then show you in Photoshop what we're going to do next in order to combine the two images to make a complete image. So as soon as that's done, I will be right back. Okay, so now we're back and we're going to open up that other file that we created, which is going to be the top half of the moon. When you have this program still opened in the background, all the settings are retained. Remember, we actually did save the actual settings that we have. If you have lost them for whatever strange reason, you can simply click on load, navigate to where that particular file is, and you just simply open it, and all those settings will just reload itself right down to the actual curve itself. Once you've done that, simply click on select all, let the thing process. It might take a minute depending on your machine, and we can just double check to make sure everything looks good, and then we can do any minor tweaks in here before we actually go ahead and save any of the files. So now that I've gone through this and I'm pretty happy with what I see here, we now need to go in and save the actual final image. So first of all, let's start with the one we open. We click on File, Save, and we're going to put this on our desktop. We're going to put it into the Moon folder. I'm going to select TIFF 16-bit, and we're going to call this one number 1. I'm then going to go back and open the other file. Make sure I select all to apply the settings to the entire image. And then I'm going to save this particular file. Again, make sure we select TIFF and number 2, just to keep things simple. Now, of course, you could always save as you go along. I try not to do that in case I actually make any tweaks here, so I don't have to keep doing this thing over and over again. So I typically open the files, do my checks, save my settings, and then make sure that both of the images look good and they're going to match together, hopefully somewhat, well, relatively good. So we're going to open up in Photoshop the 2 files that we actually saved. So there's 1 and 2 there. And there we go, we have the top half and the bottom half of the moon. And we're now going to actually stitch these images together. So what we can do is just quickly zoom in here and just take a quick look at the actual image, just to make sure that there's no weird things going on, no crazy artifacts or some kind of weird thing going on. And so far everything does seem to be pretty good. So what we're going to do is we're going to go select all, and we are going to copy, and then we're going to create a new document. And because we're combining 2 images together, we need to make sure that the actual size of our canvas that we're working on is going to be large enough to be able to hold the moon for the top and the bottom half. So we see that the width here is so much and the height here is actually less than what the width is, so we're going to just basically match the same height and the width. We're going to switch this to RGB because we will be doing some other processing here, so we just want to jump ahead of ourselves a little bit so we don't have to go into it and convert it later. So we're going to create an RGB color image even though this is monochrome, and we're going to keep it as 16-bit. And then we just get a blank file here, and then we're going to simply paste that particular frame in. We're going to go to the other side, we're going to do a select all, going to edit, copy, go back to that original file, and we're now going to paste. So now here comes the fun part. We're going to align these 2 images together to try and create one complete image. It's actually a lot easier than you think because we're working with the moon here. It's actually quite easy. You simply have whatever the layer is selected, and we make sure we have this particular tool here, which is basically the move selection tool, and we can basically slide this around. And the idea here is we're going to try and line it up to the moon. But first things first, you can probably see there is a black line that runs through the bottom here from the actual stacking. This is actually an artifact that's actually left behind from some of the frames that weren't quite lined up. Depending on how good or bad the image is, it can be quite severe, or it can be very, very minimal. This I would consider as being very, very minimal, so it's pretty good. So what we're going to do is we're just going to simply cut the bottom part off before we actually align the two frames together. So I'm just going to draw a selection tool, and I'm simply just going to delete that area so it creates me a nice sharp edge for me to do the alignment. Now there are multiple methods of making two images line up with each other, and I'm just going to use a very simple cross tool method. Basically I'm just going to draw a cross using one of the functions in Photoshop. You have to make sure you have the ruler on, because you'll see this thing here that's measured in inches in this particular case. You can turn them on or off. If you don't have it on, simply press Ctrl R and it will show you this particular ruler, I guess, for lack of a better description. And what we basically want to do is create a new guideline to actually work from. And what we're trying to do is we're going to match up two areas of the moon by using this guideline. And what I mean by that is I'm going to pick an area that I want to match against, and I'm going to use this crater right here. In fact, I'm going to use that center spot and create a target almost for me to actually have a point of reference to align this. So I'm looking at the other image and I can see the same thing here, and I'm going to pull it down and I'm going to align this so it hopefully fits directly on top. Now I can use the arrow keys on your keyboard to do any kind of fine adjustments. Each click of the keyboard, or arrow should I say, is the equivalent of 1 pixel worth of movement. And then what I'm going to do is I'm going to hide the layer and reveal the layer just to check to see how close I am. And I'm not far off, maybe a pixel off, so I can just simply nudge in the direction to where the pixel is. You will notice a tiny bit of rippling here and there. That's quite normal because, again, that's the seeing conditions changing throughout the course of the time. And what I'm also going to do is I'm going to find another area and I'm going to double check to make sure that I'm not getting any other problems like rotation. If there's a tiny bit of movement, it's okay, we can probably go ahead and ignore it. And we're going to look at where we had that edge that we cut out. The easiest way for me to do this is I simply invert the image so that then has the black becomes white and the white becomes black, and I can see where the actual seam of the actual image is. So now I know where it is roughly. I can then just double check. Oops. I can then just double check to make sure that where the seam joins that there is no bizarre looking artifact. Now let's just assume that there was an artifact. One of the neat tricks you can do is simply create a feathered edge. We're going to do a selection and we're going to make sure we have the layer that we are going to feather selected. So in this case it's layer 2. I'm going to click on select. I'm going to then go to modify and feather, and I'm going to put a number into here. So this will determine the size of the feather. It's obviously measured in pixels. 10 pixels should be typically enough. And then once it's done that, I'm just going to hit the delete button, remove the selection, and then I'm going to zoom in. I'm going to remove these guidelines for just one moment, and you can see that there is a feathered line here, and it's obviously more obvious between the black and the white here. So when I go back to invert that by pressing Ctrl I, if there were any strange looking artifact lines, it'll simply just blend in. Now, not all cases is this going to be as simple and as easy as this, but there may be a time where you might have, say, the moon slightly misaligned. What I would do is I would do another anchor point, for a lack of a better description, and I'm going to check to see if I have any rotation occurring, and if I do, I can simply do a transform by pressing Ctrl T. I can set the anchor point by holding down the Alt button, going down to this particular point here, where we had the first anchor point, holding down the Alt button and clicking there. When I go to rotate this, it'll actually rotate based upon that anchor, and I can try and line this back up again as close as I can. Obviously, in this particular case, we were pretty close as it was, so we probably don't have to worry about any of that. So now that we've done that, we actually now have the image of our moon that is now stitched together with relative ease. Again, it may be simpler, it may be harder for some of you, depending on your skill or level of skill in Photoshop. So what I'm going to do next is I'm just going to move this into the center so it's more centered. I'm now going to merge the two together. So we're going to merge the two layers so it creates one complete image. And then I'm going to go back in now and I'm going to fine-tune some of the actual details and the contrast on this, because I kind of feel like I'm losing a tiny bit of the area here, and I just want to bring up some of that punchy contrast. So we're going to go into Filters, Camera Raw, and we're going to basically play around with some of these settings here. First thing I'm going to do is I'm probably going to punch up the clarity behind this, and what that does is it will darken certain areas but keep the highlights lighter. It's a similar principle to sharpening, but it doesn't actually sharpen anything. All it does is just increases the contrast in certain areas. Play around with these sliders to find what best suits for you. Obviously don't overdo it, because you can have a tendency to overdo it and everything starts to look a little bit strange. Again, this is all a preference thing. I like to try and keep things somewhat natural, so I'm only going to do a small amount. And I'm just going to add a tiny amount of texture to this, just to pump it up some of those detail areas. I'm going to zoom out, and I kind of want to look at the entire image as a whole, and I can see that there are some areas of the moon here that are darker than the others, and I kind of want to have that be more apparent, and I'm going to do that by changing the contrast, but then taking down the highlights so that the moon does not appear to be overly bright and there are no particular hot spots in any particular area. And I feel like I'm pretty happy with that. And once you're done with that, you can play around with any other settings. If you feel your exposure's a little off, you can change that, you can darken it, lighten it. I'm pretty happy with where it is at the moment, so I'm just going to leave it alone. Last things last, I'm just going to go into the levels, and I'm just going to clip off any kind of bad detail here. There's a lot of bad detail here, so I'm just going to simply go in and just clip that area out. And if I find that it's darkening too much, I can just simply bring the midpoints back up. I don't want to go too crazy. And then we can just simply OK that. And then the final step is to basically crop out any other parts that look a little strange. There's some artifacts appearing up here, so I'm just going to remove some of those and just basically apply it all the way around so I don't get any strange areas here or there. So we end up with a relatively high resolution processed version of the moon, and hopefully you will have something very similar to this, and hopefully I will see you at the next tutorial. And don't forget, I would love to see some of your guys' posts, so like and put a comment on some of your work, and I'd love to check it out, because, you know, I love looking at pictures of space. That's what I do. Okay, and until the next time, my name is Simon. I am the Stupid Astronomer, because I do the stupid things so you don't have to, and hopefully see you at the next one.
All right, boys and girls, we are live. Welcome back to another one of our little live sessions that we've been doing since this fantastic thing that we call the coronavirus outbreak. Today, we've got pretty much something that spans all of Europe and America, essentially. So we've got the guys from Italy, Primaluce Labs. We have Mike Hatley all the way in the United Kingdom. And of course, we're going to have Losmandy, which is here located in the United States of America, Burbank specifically, if you guys must know. So for those of you who don't know about Primaluce Labs, these guys kind of burst onto the scene about 2-3 years ago. And I personally latched onto these guys, and I just like, I saw their product and it was like, holy crap, this stuff is just unreal. And it actually solved so many problems as an astronomer that I would have, especially with cable management and how do I remote into the machine? How do I do this? I don't want my laptop hanging around outside. And these guys had the solution. And as time progressed, things just kept getting better and better. And now we're up to a point with these guys where the stuff that they're coming out with is from an innovational standpoint, but more importantly is they have made it more affordable for the likes of yourself and people like me, because let's face it, I work retail, I only get paid retail money, so I can't exactly afford $10,000 on various things. So without any more further delay, Filippo, introduce yourself to us.
Thank you, Simon. You did a great job. So we can go. Okay, bye. Just kidding. Hello, everyone. Well, welcome in Italy. Really, it's 8 o'clock. It's 8 p.m. here. We just had a beautiful pizza, and so we are ready to talk with you all about what we do, how we do, and we want to show you our new headquarters, talk about our astrophotography passion, and everything, and all the questions that you may have. So I introduce myself. I'm Filippo. I'm the actual president of Primaluce Lab, and I'm here together with Omar Kauz, that is the head designer of Primaluce Lab. So he's really the man behind all the red parts and all the design things that you enjoy a lot, I know. And connected with us from US, there's Thomas Bramwell, that is our Director of Operations for North America. Hello, Tom.
Hey, everybody. How are you? How are you? I'm Tom Bramwell, and I'm just coming online with Primaluce Lab here in the US. And I'm in Southern California, not too far from where Simon is. So hopefully I'll get to see him more often. But basically a few years ago, I was kind of in the same boat as Simon was talking about earlier. I'm an astrophotographer, and I had all the same problems he had with cables. My laptop sitting out in the dark, draining batteries, tripping over things. It was a nightmare. It took forever to set things up, and
you hadn't a nice red shirt even.
I do.
Now you have.
Yeah. After I met these guys at a trade show in San Jose, I fell in love with their products and the company, and their hardware changed everything about how I do astrophotography so much that after we became friends, I felt the need to go invest in the company, and together we're going to work to improve distribution here in the US so you can get the products even quicker. So I'll have supply here, and I'll be handling repairs and doing tech support here. So hopefully we can streamline things for customers.
And you have someone that properly talks English.
Yes. Yeah. I can clean up after these guys.
Yeah, well, just be glad that I do speak some form of English.
Oh.
You speak the Queen's.
Exactly.
So that's fine. I remember still when we met Tom at the airport. He was presented to us, to our friend Giovanni from Unito Italia, that was was in charge of showing the Avalon mounts in the US. And I remember we met Tom, and we immediately fell in love.
How can you not fall in love with this guy?
And we heard what he was telling us about his experience in astrophotography. We were in the AIC 2017, and that was the show where we presented the Eagle 2. That was really a big improvement over the first generation. So do you remember, Simon?
Mm-hmm.
So
that's where my Eagle, this is the Eagle 2 that I first got when I met you. Right there.
The funniest thing is I still have my Eagle Observatory. I still use it to this day. I know that drives you crazy.
But maybe the Eagle Observatory is one of the first generation Eagles, essentially. Was the generation that we presented in 2015. And there were already 3 different Eagles, so the basic model, the S model, and the observatory model. We should have one somewhere. So I think we still have one somewhere.
Oh, I can go get mine.
I don't have one.
And I remember that before entering in the show and showing really the Eagle, the Eagle 2, Tom was telling us all these adventures in astrophotography that was partially solved by the use of the Arco mount because of no more flip needed. Oh, there you go.
This comes from the museum.
This is in our museum. So this is the first generation of the Eagle. There you go.
My God, you even still have the original box.
Yes. Yeah. We have one. It's just for the museum.
So are we going to see that on eBay in a minute? You know, for like double the price.
I don't know. We'll see. We'll see in the future. We have to wait a few years more. So. And when we met Tom, he was describing me all his problem without knowing what was going on with the Eagle 2, essentially.
I had no idea what the Eagle was. I had no idea what it even was.
There you go.
Yeah.
So when we showed the day after, because we just landed in San Jose, and you came and took us with your car, and then the next day we opened the box of the Eagle 2 for the first time.
Yeah, blew my mind. Blew my mind. They showed me this thing that you can just bolt to your telescope, and then all of a sudden now all my cables are this long instead of, you know, I used to have coils of cables that I would string through my mount so they wouldn't snag on anything, and stringing those all through one at a time so they fit through the opening. It just took forever. Like setting up took forever. And then after I got the Eagle, my setup time went from 45 minutes to an hour to like 5-10 minutes. Plop it on there, hook up a few cables, and wait for dark to do my polar alignment.
So that's the thing about the what really got me was you could just leave it on your system and just roll out the door with it, and you didn't have to worry about so much. That was the great thing of it to me.
Yeah.
But let's, you know what, Tom, show us how the Eagle works. I mean, I'm sure it's great us talking about it and seeing what it looks like, but I think more importantly for the people that are watching is, how does this thing work? Because I think some people who don't quite understand it, when they see it, it's like that aha moment.
Yeah. Well, I had a hard time wrapping my brain around what exactly it was at first too. And that basically the way I look at it is, if you take your laptop that you use for imaging and you take the screen off of it that's delicate and cumbersome, and you put it in a small compact case that bolts to your telescope, right? It's basically a computer that runs Windows, no different than your laptop. But where it does become different is that it also manages your power. So it has 4 12-volt power out ports, and it has 3 variable 12-volt ports for dew heaters. So this thing, yeah, see, he's pointing to them there. And this thing eliminates a ton of hardware from your setup. So it cuts out a dew heater controller. It cuts out all the power bricks and power supplies that you had to hook up all your cameras and mounts to. And it handles it in one compact space. So like I can show you on my telescope here. I can hold my laptop. Right. So I have ultimately one cable coming down to the ground for power for this whole thing. And all the rest of my cabling is all up here on the mount that revolves with it. So no issues with cable wrap. Everything revolves nice, nothing snags. I don't have to worry
as you can see, as you can see over there, so we have one eagle here that is connected on top of the telescope. Tommy is using the eagle as a structural element.
Mm-hmm.
So the eagle has been designed in order to mechanically behave like a bar, essentially. So you can even install on the eagle, on top of the eagle, not very heavy. You can't install a huge telescope, of course, but you can install it in between the support rings and a dovetail, for example, like Tom does. So instead of having to use the Avalon extender that prevents the telescope to touch the rear part of the mount over there, he used the eagle as an extender, and there's no way that the telescope on top of the eagle will move, because someone, that is him, correctly designed it. So
yeah, the mounting system has no flexure whatsoever, so I don't have to worry about anything shifting over the course of the night, which is really important for my mount because my mount doesn't flip at the meridian. And eventually at the end of the night, my rig is completely upside down. So if I had any kind of flexure whatsoever, I would be punished. The minute I crossed the meridian, everything would shift.
Yeah.
So it's really, really solid. But yeah, once I have it all cabled up, if you want, I can show you the UI and kind of show you how I get rolling. It's pretty easy.
It would be great, Tom.
Yeah, so basically now with the eagle on the telescope, I'm free to go wherever I want within Wi-Fi range. So typically what I do is I go in my Jeep where it's safe because I shoot out in the wildlife. And I like to go into my Jeep and Astro from in there. But I'll share my screen here. Do you see my screen?
Yep, we can see you.
Yeah, we see it.
Yeah. So when I first connect to the Eagle over remote desktop, basically this is what I see. Underneath the Eagle, it's regular windows, just like you would have on a normal PC. But when
beautiful picture, Tom.
Oh, thank you. This is actually, I'm shooting this in my backyard right now. This is a work in progress.
Is this the brand new one?
Yeah, this is brand new.
Wow.
Yeah. So I shot this last week in my backyard here in Oceanside. But when you first turn the Eagle on, this is what you see. You see the Eagle Manager. And so basically, it's a representation of your Eagle here on the screen. Here you can see your power output ports. Here are your dew heater bands. These are USB 2 and USB 3 ports. And here we have what we call our Echo module, which is our environmental, the computerized control. And it will automatically monitor the temperature and humidity and calculate the dew point, and then apply heat automatically to my dew band based on what it calculates. So I don't have to constantly drain my battery, guessing when the dew is going to form. The Echo does it for me.
Echo, so what does it mean, Echo, in English, Tom?
Oh, Echo in Italian means there you go.
There you go.
There you go. Echo.
Because it works automatically without having to connect to external software. It runs deeply integrated with the Eagle, so it can't be connected as a standalone system. but
Yeah.
it works automatically with Eagle when you simply connect it to the USB port of the Eagle, and it works together with it. So Echo, there you go.
That's the
There
little
you go.
Echo module right there. And so you hook up your temperature probes here and USB on this side, and then it takes care of the rest. So then, yeah, typically what I do when I first connect is I'll come in here and I will connect to my pole master camera, which is covered and I'm inside, so you can't see anything. But I'll run through a polar alignment here, which is very, very easy and quick. And then when I'm done, I'll disconnect from the camera. And I usually disconnect it from my mount as well and put it in a bag. But then once I'm polar aligned, I come in and I just turn on all my devices. So I'll come and power on my mount. I'll come and power on my QSI, which I'll hear it boot, beep, beep, beep. And then power up my focus motor here. So I currently have a Sesto Senso hooked up to the Feather Touch on this telescope. If I can get to this side. So it had a really robust Feather Touch 3-inch focuser on it that I was pretty fond of. So the easiest way to mechanize that was to just install a Sesto Senso motor on it. And now I have full automation of it. And that eliminated an external focus controller and a bunch of extra cabling when it's just this nice, simple, compact unit. So now that everything is powered up, basically I just go into my Sequence Generator Pro. And I have a sequence all set up. This is the one actually I was showing you that I was shooting in my backyard of M27.
So Tom, what we are looking at right now is the desktop of your Mac computer.
Correct.
That is actually Wi-Fi connected to the Eagle.
Yeah. Yeah. So you can connect over Wi-Fi from pretty much any device that will run Windows Remote Desktop. So Mac, PC, iPad, iPhone, Windows tablet, yeah, anything.
Android devices.
Yeah, Android. The Windows Remote Desktop is a free client for download from any of the app stores.
And the license is included in the Eagle, so you don't have to buy an external app. You don't have to use VNC and install the Eagle in order to use it, because the Eagle is essentially working like a router. So
yeah, sometimes I like to start my evening on my laptop because I have a full keyboard and it's more convenient for changing any settings. But once I'm rolling and I go in the Jeep, I start watching movies on an iPad. And I like to just kind of swipe over and check my guiding on my iPad and then swipe back and get back to the movie. So it's super convenient, really, from any device. But yeah, once I'm in here, basically, I just go into my planetarium or my control software here, Sequence Generator Pro, and I'll connect to my camera and filter wheel and connect to the Sesto Senso. It shows my current focus position is 0. And I'll connect to my mount. At this point, I'm pretty much ready to plate solve and get going on my imaging run. I'd go calibrate my, my guide camera down here with PhD2, launch that, do a connect all to all my devices. I'm ready to do a calibration in PhD2, quick and easy. No more messing around with all that hardware wasting dark time.
and everything that is doing Tom right now is through the Wi-Fi. Mm-hmm. So there is really no cable connecting the computer that is using Tom to stream his screen in this moment. He is actually connected to the Wi-Fi. So that essentially was the original idea that we had to convert into a Wi-Fi system any different device. So Wi-Fi enabled mount control, Wi-Fi enabled camera, and But the problem was that you were expected still to connect to all the different Wi-Fi systems. And that was not easy. So the idea was, why don't we move the computer to the telescope and we still connect all the devices with short cable on this computer that is on the telescope, and then we stream the image remotely with the Wi-Fi, so you simply can stay in your house and you have your telescope outside, and whatever device you have that is Wi-Fi enabled, you can simply connect it to the Eagle Wi-Fi and you remotely see what's going on outside in your telescope.
Very liberating.
Yeah.
So I'm just going to show everybody a picture of potential setups. So right now, this is my Instagram. You can see, you guys won't be able to see it because this is only on the live stream, but just imagine a very, very messy setup right now. I'll show you the picture another time. This is basically the EQ8 RH Pro with an Esprit 150, and this is a very big mount with a very big scope, and you can imagine the sheer amount of cables that are just dangling around all over the place. Now, the goal here was, when I was going to a remote image site, is I don't want to trip over anything. I don't want cables dragging on the ground. I don't want to have things sticking out that can be snagged. So the actual setup ended up being something like this, where you can see the battery is attached to my pier mount, and then everything else is contained within the Eagle as well as the actual telescope. And notice, this is actually a fully functional system. Nothing touches the ground, which is the critical part. So you can imagine if you're at a star party, there's a lot of people wandering around, or you're trying to do some kind of unique setup, you can see how tidy this can get and how useful this can actually become. I think, Filippo, you guys probably don't stress enough on how, from a remote side of imaging, that this essential system is more about the cable management side of things and the trip hazards and making it simplistic. And I think that, to me, especially for a lot of us, because not all of us have luxuries of dark skies, especially if you live here in LA, we've got to drive somewhere. And this is the most common thing that I see, is somebody is always struggling with a laptop, they're fighting with something, and 9 times out of 10, I go up to them and say, look, what are you doing? And then I just see this whopping great big long USB cable. I'm like, dude, you're too long with your USB cable, and you've got this hub, and everything seems to boil down to this one connection. And that's why, I mean, I know you don't like it when I say this, but I always say to people, the Eagle at the end of the day, to me, is the world's most expensive zip tie. But does it solve a problem? Yes, it does. And I can't stress that anymore. And I've sold countless units when somebody sees that setup and go, that's what we want. This is the thing to solve that problem.
Mm-hmm. Well, you know, Simon, I used to tell this story when we are together at the trade shows and talking to the people about the experience, where the Eagle idea comes from. And I know Omar from a very long time, because we were A-Bob days. Okay, so it's a long time. So we started imaging together, and we had experienced all the different telescopes. We really lived on the digital revolution of the first DSLRs, digital DSLRs, not affordable DSLRs. So this is our story as astrophotographers. And there were one night, we finally had a big equatorial mount, can't remember the name, but it was big. And we had an RC telescope, we had the cooled camera, all the typical system right now. So it was quite big for the time. The problem was that it was so complicated that it even needed 2 laptops to run everything, okay? So, and here is not LA, but still we have very light polluted skies. So what we were doing, me and Omar, was loading together, because for one people it was simply too high, the weight was too heavy, and we had a 120 amps battery, 120.
That's huge.
And yeah, because we had 2 laptops and everything, so it was a table, camp table, chairs like this and everything, just for one telescope. And we had to go to the mountains, and we had a bunch of cable running everywhere, and it was a nightmare. So usually we took too close to 2 hours to prepare everything and to load everything properly in the car, then move to the mountain, another hour, and then when we arrived, I still remember that night, we removed everything from the car, we prepared the setup, we made the power alignment, we connected all the cables, all except one. Because we forgot one cable. I can't remember if it was a power cable, a USB cable, I can't remember. But it was 2013, I think. And simply we came back. So there was nothing to do. And we reloaded the cable in the car, and then we went back at home. And I told Omar, what we do now is something that people is experiencing even. So we have to improve this thing. Because it's getting crazy to move with the laptops in really the field where you have no power, and simply is too dangerous. The possibility that you have a problem by uninstalling and removing all the single elements that compose your telescope is so high that simply is really, there's really a big possibility that you forget a cable, like me. And that was the idea behind the window. And so the next step was essentially, has been to think it as a unique unit, an entire unit, including the computer, a sort of USB hub, a power hub, and everything. So we didn't want to design something that, like, there are already in the market, USB hub, power distribution hub, and then you have to connect everything and make it work. There's one possibility, but we wanted to do more. And we wanted to make a brick, a red brick that has it all. And this way, you simply have it on your computer, you install, and then you can go and have everything already prepared, and it simplifies your life. Of course, as you said, it's not a cheap product. We are not a Taiwanese company that makes 1 million of computers every month. This is not. So we produce all our products. Well, we can go. Do you want to make a factory tour?
Yeah.
Yeah,
why
we
not?
have a
We are
new
here.
factory. Yeah.
Okay, let's go for the factory tour. So we can show you how we produce everything. Okay, so you can see. Let's see if, let me see. Do you think it will invert? I think it will invert the camera.
There you go. Yeah.
Yep.
There you
Yep,
go.
perfect.
So Omar can be my cameraman. Okay. Okay. Guarda che non vedi. Can you see me? Okay. So essentially, well, this is the entrance, and then it's a very cloudy day today.
It's raining.
We have where we were sitting here. We have a small showroom where we show our products, and upstairs we have all the offices. But I want to show you what we have on the back that is more interesting. This is where we build all these small and big or huge products, but I want to talk to you later about this. In the new headquarters, we designed a lab that is divided from the other part of the workshop where we create and we prepare the big instruments. And we have an electronic lab where we essentially we assemble, we test all the devices. So here you have, and this is where the most of the Primaluce Lab people, workers, work actually every day. So this is, we have not much a lot because they already prepared a lot, but essentially we were talking about the structural function of the eagle, and I want to show you how it's made. So these are the two parts that we connect and we design to be a unique element, like a unibody. It's not really a unibody because we have to open and install all the electronic parts, but this is the eagle. And essentially here, the operators assemble, test properly. For example, this is actually the work of Massimo, one of our specialized technicians that essentially test all the electric loads of the eagle one by one. So you know that when you receive an eagle, every eagle is tested by an operator, and it's really, he turned on, he checked for all the settings, he checks for the USB port features, the functionalities, he checks for the electrical distribution system in order to check that everything works properly. And of course, an eagle has a lot of parts embedded in. So you don't have to have a USB hub, and you don't have to have an electronic distribution system. It's Wi-Fi enabled. So everything is built into the single unit. Of course, this makes this system not the most, the cheapest thing, but this is not what we call cheap. We call it affordable. That's, I think it's different. Am I using the right word?
Yes, yes, yes. It's an affordable thing.
Yeah, okay. It's cheap I think cheap is a sort of negative term, isn't it? Affordable is more.
Cheap is quality.
Yeah, cheap is quality. So we don't want to have cheap things. We want to make it affordable. That's different. Well, this is where a lot of people works here. Well, I can introduce you on also other products. What is Omar doing right now? Woo! Can you see that? Yeah.
New toys.
This is the new toy.
Oh, I think we might be losing those guys out there.
Oh, the internet is going to deny.
Are you losing me?
Oh, yeah, we're losing you. Do you want to reconnect onto the other Wi-Fi?
Or yeah, or maybe we can go closer to the. Is it better right now?
Yeah.
Better.
Okay, wonderful. So we came closer to the Wi-Fi antenna. So Omar was showing you the Arco, the brand new product that actually we are creating here and we are developing. It's a rotator that is fully integrated with our focusing solution. That means the Esatto, like this, or the Sesto Senso 2. So in both the Esatto and the Sesto Senso 2, the Esatto is the focuser. This is the Esatto 3. Oh, we have all of them. Okay, we have here all of them. So the Esatto 4 inches, the brand new one, the Esatto 3 inches, and the Esatto 2 inches. These are our complete focuser. So it's a high load capacity focuser built in with the Sesto Senso technology, essentially. Okay, and then we have the focusing motor that Tom was referring to, and this is the Sesto Senso 2. And if you take a look at them all, you can see that we already added to the Sesto Senso 2 and to the Esatto the Arco port. Arco is what we call the arc second rotator. And it's the rotator that we are actually developing. Well, we can say, Omar, that the hardware is already finalized.
Yes.
Okay. So the hardware is this one. So is thin, is 20 millimeter thickness, optical thickness, is 21 with the adapter that connects it to the Esatto in this case. And you can connect the Arco to the Esatto with this single port. So you don't have to have an external USB cable to your Eagle or to your external computer. You don't have to have a 12 volts power port, because data and power is directly taken from the Esatto or the Sesto Senso to the Arco. So it's a very handy and easy way in order to remove other cables and have just a short one to make it move, because this will essentially move this way and following the focuser draw tube, and then it will rotate the camera this way. But that's a brand new thing, so it's a really preview. Don't tell anyone. Can you hear me? I can't hear you anymore.
I can't hear Simon.
Ah, okay.
Sorry. Yeah, sorry. I think there's a lot of people who are waiting for that device to come out, because I do get asked about that quite frequently, and it's really good to see how far in development. And this is a great thing. You guys don't rush products out just for the sake of getting sales. It's like it doesn't come out until it's ready, and it's so good to see it at this point now, because I think a lot of people have been waiting for this. So I think there's an obvious question: what payload can it handle?
The same payload of the Esatto. So there is no limit on the Arco because of its properly designed. So the Arco will be around 1 kilo. So if the Esatto 2 inches,
there will be two models.
There will be 2 models of the Arco, but essentially this is the 2 inches model, and then we will have the 3 inches model. The 2 inches model will allow you to load up to 4 kilos cameras. Okay, so if your Esatto 2 inches has a 5 kilo payload capacity, in pounds are 10, 11?
About 10 pounds.
Okay, and you have 1 kilo for the Arco, so you have 4 kilos left. And this is exactly the payload capacity of the Arco. Okay, so we designed that this way because it's fully integrated into the Esatto. And the Arco 3 inches will have a larger free aperture, of course, in order to let you have the same free aperture of the larger 3 inches, and to have even more payload capacity. So essentially, you will be able to choose the Arco version you prefer. The Arco 2 inches will go on the Esatto 2 and 3. The Arco 3 inches will go on the Esatto 3 and 4. So you will be able to really create your imaging train in the perfect way that match with the type of camera and accessories that you really have.
Cool. Real quick question online here to Tom. Yep. They were asking, what software were you using with the Eagle? So needless to say, the Eagle Manager is unique to the Eagle only. You can't just download it and put it into your PC. Okay, that's for the Eagle specifically. And what was the other software that you were using?
Well, other softwares I use, let me go back to it. Okay. So when I first start out, I use Paul Master for all of my alignment. And then once I'm done there, typically for my pointing, I will use Carte du Ciel, which is a free program. Basically, it can just connect to my mount here. Connect. And then what I'll usually do here is point south. Got windows covering my So I'll just like point south and pick a star somewhere close enough, and then do a sync. And now my mount is running basically. So once I do that, I put that away. Oh, wrong window. After I do my pointing, I use Sequence Generator Pro currently. So I will go and connect all my hardware in SGP and begin my imaging run from there. Also for guiding, I use PhD2.
Cool. And this is one of the questions that we really reply to most of the time. That is, but what software can the Eagle use? And the reply is any, because essentially the Eagle includes a Windows computer. So you take advantage of having a universal computer built into your telescope that allows you to upload any type of astrophotography Windows software. There are many, free or paid, whatever you want. And you can install any type of device because all the manufacturers provide their device with Windows driver. And this makes Windows a universal platform for astrophotography, because this is actually. And this way, if you have an Eagle now and whatever device you will want to buy in the future, you will always find Windows driver. So it will always work with Eagle.
I mean, the unique thing here is the only software that is specific to the Eagle is the Eagle Manager. That's the only thing that's unique to it.
That is provided with Eagle.
Right, which is provided. So for people who are looking at something like this, you have to understand this is not a custom OS. This is not some weird thing that you have to get used to. I mean, obviously, if you're a Mac user and you're not a big fan of Windows, you know, it takes a little bit of getting used to, but it doesn't take a long time. The idea here is they've designed the interface, especially the Eagle Manager, to be touchscreen, because you're not necessarily going to drag a keyboard out to the field. So that's why they've made the interface touch enabled. And it works really nicely in that fashion, especially when you've got yourself a small little phone. Well, mine's not small by any means, but if you're using a phone, it's actually a lot easier to use. I will admit some programs like Sequence Generator Pro can be a little bit fiddly when it comes down to using a small cell phone. So I do suggest that you do get a tablet device of some description.
Yeah, I think having a tablet is kind of the baseline for ease of use. A phone is possible, and if you're stuck, a phone will connect and absolutely is usable. It's not very enjoyable because of the screen size. A tablet is better. I prefer a laptop, like even like a simple, inexpensive Chromebook.
Oh yeah, they work great.
Yeah, so it gives you a keyboard and a comfortable pointing device, like a trackpad.
Yeah, that's because you use the device not as a device itself. You use it as a screen, as a keyboard, as a mouse, and that's all.
Yeah.
So all the pictures are saved in the Eagle because the Eagle has an SSD drive to save the Eagle, and then you can move your picture. You can connect a USB pen, for example, and you can move it. Or you can move, if you have your Eagle connected to your home network, you can transfer files very simply over there. So, but Eagle is...
Okay. Well, I was going to say, well, a lot of time what I do is when I go out imaging, I throw a USB 3 stick in and I write all my images directly to the stick. So when I'm done at the end of the night, I pull that thing out and I'll go process on my Mac.
And another good thing that I think also Simon enjoys a lot is that the Eagle is a great system also for planetary, solar and moon imaging, because it has a fast SSD drive and it's as big as you need in order to save very large video files. So you can connect your planetary cam to the Eagle with a short USB 3 cable, for example, and save your video file in the Eagle in the same moment that you are looking at the picture streamed to your remote device, but it's not. It's like you are just looking at the streamed picture, and the file is saved quickly on your Eagle. So it's a great device even for planetary imaging.
So here's, for those of you who are hardware nerds out there, because I am one, the problem here with doing any type of high-speed imaging with a laptop is the USB controller. That is always the #1 problem. So naturally, most laptops generally have, say, 2 USB 3s and 1 USB 2, or possibly 2, depending on who makes your laptop. But the big problem here is with most laptops is the USB 3 bus is shared over 1 PCI Express lane. What that basically means here is think of 2 cars trying to go down 1 road. The great thing about the Eagle 3 specifically is you have a separated USB 2 hub, which has traffic routing from one way. And then they have independent USB 3 ports that are darted all over the Eagle. On my particular case, I have up to 4, I think. The good thing here is I know one side of the USB hub for the USB 3 connector is not the same part as the other one. So in other words, I have 2 physical separate lanes coming in. And what that means is I can plug in my camera into one side of the USB 3 ports, and then everything else can go in the USB 2 or the USB 3. So I will always get maximum bandwidth. And because I always get asked, how do you achieve 130 frames, 160 frames, or even 230 frames a second and still record? It's because I'm able to separate the USB traffic coming in. You have to remember, the Eagle is just like using a desktop PC. The only difference here is it's just been miniaturized and it's on your telescope. That's the big thing.
Yeah.
So it's not just some little toy box that they came up with. It's not some plasticky thing with a Raspberry Pi built into it. This is a full-blown Windows 10 PC. And this is the part that you haven't spoken about, is the Eagle comes in 3 different forms, or even 4 in some cases. So do you want to go through that so people understand the differences?
Sure. Well, externally, if you look all the different Eagles, let's go over there. But what do we have here? I don't know really. So we have, well, these are all Eagle Pro. These are, and this is the basic Eagle. So let me open one for you. Let's see.
Oh, Massimo's going to kill you for opening that.
Will kill me tomorrow.
Yeah, I know you will. That's what I just said. He's going to kill you.
Yeah. It's okay. Sorry, Massimo. So
no longer inspected by Massimo.
Yeah, this one's hand inspected by Filippo. What serial number is that?
Inspected. This is special. So you see, this is the Eagle Pro. That is the top line. And this is the basic Eagle. This is the basic one. And essentially, they are really the same. Okay, it's the differences are really small if you look at externally. What changes the internal part, because the basic version of the Eagle 3, is the most affordable one. It comes with a Celeron processor with 4 GB of RAM memory and 120 gig of SSD drive. Okay. Then we have the Eagle 3S, that is an i3 processor, 8 GB of RAM and 250 gig of SSD. And then we have the Eagle 3 Pro, that is an i5 processor, 16 GB of RAM and half a terabyte of SSD disk. So essentially, all the 3 different Eagles share the same features. They have all the 8 USB ports. They have the 4 12 volts power out port, the 3 new heaters port, the full aluminum case, structural, and they have all the same feature. But the difference is related to the computer side. So you have more power.
Yeah, so for those of you, if you're just doing a basic imaging rig setup, then the the Eagle 3 would be the best scenario. If you're looking into doing a little bit more power or you need a bit more throughput, that's where the S comes in. And if you do what I'm doing a lot of the times, especially with high-speed imaging, the Eagle Pro is probably the more critical part to this. Now, speaking of affordable, what if I was just a DSLR photographer? I just want something very, very basic. I don't want to spend that kind of money because it's just almost too much.
Yeah. That's why we designed a special version of the Eagle. Well, I should say he designed a special version of Eagle. And I will show you a system that is already installed. Sorry for my finger, but I'm trying to change the camera. So, okay, there you go. So this is the Eagle core. That essentially is a small version of the Eagle, very affordable, that is installed on the telescope in the same way that the Eagle does, that has the Wi-Fi connection in the same way that the Eagle does, but it's designed specifically for DSLRs and mirrorless astrophotographers. So when we designed this unit, we were thinking, okay, we are astrophotographer, we want to make this type of pictures, we want to have the best result, and in order to do this, we have to have a lot of devices. But the reality is that we are just part of the story. We are experienced astrophotographers. So we already had our long, how do you say, the knowledge curve? I don't know in English.
Learning curve?
Learning curve. Sorry, thank you, Tom. Learning curve.
That's why I'm here. That's why they hired me. Yeah.
Okay. And essentially, maybe you just want to start in astrophotography, so you don't need big telescope with a lot of devices. But what you need is simplicity. Okay. Most probably, if I'm thinking about people doing astrophotography, if you show an astrophotography software, they can get crazy because they say, sorry, there are too many things. It's too difficult. Okay. So we wanted to provide an hardware and a software that was very easy to use. And this is where the Eagle core came. So essentially, you have the same type of device. You always have also the distribution power here. So the idea is always the same, to have a computer that is built into your telescope, that is structural, so you can install like this way the Eagle in your on top of your telescope, thanks to the plus system that he designed. and you see all the red parts that we have here are the plus system. Plus system is a Primaluce universal system because it allows you to integrate the Eagle in any type of telescope. And the difference between the Eagle core and the Eagle is that here is more affordable and more simple also system with less ports, because most probably you don't need 8 USB devices to make DSLR or mirrorless photography. But the difference, the most important one, is that this already comes with an astrophotography software built in that we designed. So it's really a plug-and-play system, and you don't have to install software. You can't even install software. It's preloaded with a software that we designed for DSLR and mirror image. And what you do is that you can take control of your camera, you can take control of the autoguider, you can take control of the sexto sensor or the autofocus, and you can take control of the mount. So essentially, like in the Eagle, you have the full remote control of your system that is properly powered without all the bunch of cables and power units. So you don't need to just have one cable going here. I haven't a power unit to show you here, but and it comes with a very simple to use interface that shows you the picture in real time, so you can focus, you can check your autoguider if it works, if it's in focus position. You can have the autoguider, the guiding graph. You can focus perfectly your telescope, and then you can save your picture. That are stored no more in the Eagle, because this Eagle core has not an SSD drive, but the pictures are saved in RAW format on your camera directly, as you would do with an external trigger, okay? But having an entire system that control all the most important parts of your telescope.
It's like the most serious intervalometer that was ever created.
It is. I mean, that's exactly what it is.
Yeah, that's an intervalometer with autoguider and focus control.
Cool.
It's like a astrophotography appliance for DSLR. Really, it's you turn it on and it works, but one way.
Yeah, and you don't have to install drivers here. So you simply plug your USB device. It's automatically recognized by the Eagle core, and it works. Of course, you have less features. So here, Eagle, you can connect any type of device, and you can use any type of software. So it's really a universal system, and that allows you to do anything you want with it. Okay? Not the coffee or something like that, but astrophotography.
Anything on Windows. Anything on Windows.
Anything on Windows, exactly. Okay.
Here you have less features, of course, but is a plug and play system. So anyone without knowing computers, they can use the Eagle core. It's just plug and play. You just have to check that you have an autoguider that is among the compatibility list, and you have a camera that is supported by Eagle core, of course. We are adding more and more cameras for every release of the firmware that we regularly release, and you can apply the new firmware for free. You can download, apply the new firmware, you get more features. We just released one new feature by adding one firmware by adding more features in it. So it's a very simple way in order to start. And one of the things that I like the most of the Eagle core is that it's really helping also photographers. So not only amateur astronomers that want to start in astrophotography with something that is simple to use, but this helps also people that is not used to astronomy in general. And we see many people making experience with the Eagle core and then moving to the Eagle when they are ready in buying code cameras and all the other devices. And the thing that I like the most is that in this process, most of the people are not selling their Eagle core because they keep it as a very simple to use system when they want to make astrophotography in the easiest way, when they are traveling, for example. So they still have both, because the Eagle core is not a simple Eagle, it's not a cheap Eagle, it's a different system. That's for simplicity, that's because it's really powerful and universal.
Yeah. Real quick, Filippo, do you want to go back into the lab, because there's less echo there, so we can hear you better? Because there's a couple of questions that we're gonna go into Q&A now. So we've got about 15 more minutes roughly. So let me start with this obvious one. It's going to be me and Tom while he migrates all the way back in there.
I'll sit still. Yeah.
Yeah. So Tom, powering the Eagle. That's always been one of the biggest questions. Now, needless to say, of course, you can power it with AC.
Correct.
What methods of powering the Eagle do you have?
So when I'm at home, obviously, I do go off of an AC adapter. I have like a 10 amp power adapter that I hook up. When I go out in the field, I am obviously on DC power. It runs quite well off DC. There are some things you need to be aware of. We require that you run a voltage regulator. that will not allow the battery to dip below a specified level. And I think we like around 12.3 volts, I think.
Yeah, 12.3 is the lowest it will go before problems start.
Yeah, so the Eagle can actually be damaged if you run it in an undervolt situation. So we require that you put a voltage regulator on your battery. And I typically recommend something like maybe 30 amp hour or higher. Personally, I have learned over many nights of bleeding that I eventually went with a lithium battery. I can show you my battery. It's right here.
So while he tries to lift that up, I'm going to make a big point here. You have to understand that a battery at the end of the day is still a giant voltage regulator. However, there is nothing that regulates its voltage output when it dips or if it jumps back up. We normally call this line sag. So the more load you put onto a battery, the lower the voltage drops. So you got to remember that's not what a battery, why they call it a giant voltage regulator. That's not how a battery actually works. So you have to have something in between that system to protect it. So do I recommend plugging in car batteries directly into the Eagle? Yes, you can use that, but I don't personally recommend it. So
Yeah.
what did you just have?
Work for a while until that voltage drops down.
Right.
And all of a sudden you're going to shut off, and you may have damaged your Eagle.
Well, the good thing actually here is, though, the Eagle does have built-in fuses which are not user serviceable. So please do not open them up and try to replace the fuses because you can't. But there is some level of power safety built into the Eagle. They do have fuses. They do know if the voltage drops. The Eagle is designed to shut down as quick as it can if it detects the voltage has dropped down below a certain point. So just be aware of that. If you do have intermittent power issues, check your battery or your power source first. It will be always the thing. So sorry to make you pick that thing up again. What was that?
A lot of new batteries are coming where they put out almost exactly 12 volts, which is not adequate. And like there's a battery called the Jackery that is pretty popular. But a lot of those are kind of designed to put out clean 12 volt power to like a CPAP machine. They don't like higher voltages. So a lot of those require like a special cable that takes it up to like 12.5 volt. I use a Yeti battery, which is a lithium ion pack. This thing actually will run 2 nights for me, which is wonderful. It has a solar panel that I can hook up to it easily. But this has a module that I can plug in that gives me 12.5 volts steady, all the way down to the end of the battery.
So now I've actually gone out of my way to test with current products that are out on the market from the astronomy side of things, what powers an Eagle. I can actually turn around and say that Celestron makes the Lithium Pro. Now you've got to get the Pro version. Yeah. I've had that thing running for 7 hours with load. Now I'm not slewing all over the place. I'll slew once, go to the object, and I'll image it for say 5 hours, and I still have battery to spare.
Now this is their new power tank?
That's the new power tank. You can actually use that, and it's been fully tested. I've actually tried it. In fact, the picture that I showed you with my EQ8 RH Pro and all that kind of gubbins, that was with the power tank Lithium Pro.
Yeah, the previous power tanks didn't really live up to the challenge. They were meant for a little bit lighter detail, I think.
Yeah, it was just a
power. I had heard good things about the new Pro. That's cool to know.
Yeah, the fact is that the Eagle distributes the power that you really need. So the power needs that you may have depends on what you connect and what you power through the Eagle. So this is really a variable thing, because you could have, if you especially consider the cooled cameras that are the biggest power consumption devices that we usually have, except for such big mount. Essentially, it depends on what you have to power. So when you connect a lot of devices, as you correctly said, Simon, is you have a slight voltage droppage, as you tension voltage droppage.
Yep.
Dropping.
Yeah, is it the right word in English?
Yeah, it's the right word.
Ah, okay. Sorry. And so you need to take care of that. I mean, you have to provide the right power to the eagle that will distribute the power to all the other devices. But that's all.
And this is the thing. This is not just with the Eagle. This is with any electronic device that is requires a higher amperage to power. 9 times out of 10, why any telescope tends to fail is because the voltage is what is dropping or spiking. If you're powering everything through the Eagle, which you should be anyway if you're using the Eagle, fire up your desktop again real quick so they can see it in the Eagle Manager, because it does show you the voltage coming in and the voltage going out. So you can actually see how many watts it's consuming and how many amps that your particular device is consuming.
Like, let me go turn, I can go turn the fan on.
Yeah, let's do that, just so people get the idea. And then we have one more question to deal with. It's a 2-part question, but stay in the lab because I know all the parts are in the lab.
Okay.
All right, so the fan is spinning up now, and now you can see the power consumption go way up.
So yeah, most mounts on average when they slew usually take about 1 to 2 amps. Now remember, you're not slewing 24 hours a day, 7 days a week, but when it's not slewing, most mounts use 0.1, maybe 0.3 of an amp, if that. Camera cooling is 1 and 1.5, as we can see. The Sesta Senso doesn't even take 0.1 of an amp. It's like nothing.
Yeah. It's very low.
And now the Eagle itself, I believe, if you have the Pro, at least with my one, I average roughly 1.3 amps, depending on how crazy I'm going.
I can focus my camera and hop out and see how much the Sesto Senso is gonna clobber it. Let's see.
And that's a big advantage of has the Eagle over a laptop, that the power consumption of the computer itself is a lot lower than a laptop in the field. So you already save a lot of power, and if you move from a laptop to the Eagle and then you connect the same devices, you will end up with the need of a smaller battery.
So focusing, I'm using 0.2 amps on my Sesto.
It's nothing. Yeah. And again, we're not backing in and out all night long. I mean, that was what, 2 seconds, maybe.
The designer says that is a correct that it's a correct value.
Okay, so the next question is, how much does the Eagle weigh?
It's a 1 kilo. Let me 1.2. But we can show you. I think but it's 1.2. Yeah.
So 1.2 kilos is what? 2.6 pounds. Yeah, 2.6 roughly.
2.6. Yeah. So we have a lot of people even using the Eagle as a counterweight.
Yes, I do the same thing.
Let me show you this here.
That was weird. He went out that way and then he came back out through that door.
Yeah. He's his place. He knows everything about this place.
So this is my Edge 1100 setup.
Oh, there you go.
Yeah, here I use the Eagle as a counterweight down below.
Yeah.
So that ends up being that, and then this little white brick ends up being my entire counterweight for this whole setup. Well, that plus the arm of the mount.
Well, yeah.
Yeah. But yeah.
So this improves portability a lot because...
Oh yeah, I don't have to carry anything out to the field now for counterweight. This is wonderful.
And when I was using that mount, I remember I was the same. I had the same mount. That was it's your M1.
That's my M1, yeah.
Okay. And I was moving with the mount head on a large box with the Eagle connected, so all the cable were already prepared and connected to everything essentially. So you can open your tripod, then you put the mount head on top that already comes with the Eagle and all the cables already connected. So it's really a matter of a few minutes in order to have the mount, the entire telescope prepared and aligned on the field. So it's a very
I
easy thing.
move my entire rig from the Eagle up together as a unit and just place it right on there when I go to image done.
So next question, part of the question is mounting options, which I know we touched on the Plus system lightly, but I think we kind of need to go into it.
Yeah.
Do you want to pick up an Eagle real fast and show them the hole patterns? Now, this is important because there is multiple ways to connect an Eagle to a telescope. You don't have to just do a dovetail rail and a clamp. You can actually get the actual Primaluce the Primaluce telescope rings and pass screws straight through that bolt directly on. So the Eagle becomes part of the dovetail connection without using any clamps. Now, for my setup, I prefer to have it on a dovetail that I can slide backwards and forwards because I like to use it as a counterweight or a counterbalance as well. So there you can
on my rig, I have mine connected to a rail, and then I slide it in and out of a saddle, just like you said.
Yeah, and this is one of the simplest way in order to clamp the Eagle as a counterweight to any type of telescope that comes with a Vixen style or Losmandy style dovetail bar. So you have one of the part of our Plus system is this clamp that has the same screws, the same holes that you find in the Eagle here. So essentially, when you connect it, you can fix it on the Eagle with multiple screws, and then you can use the Eagle as a moving counterweight. So you can even use it in order to perfectly balance your telescope system. This is one of the easiest way. And this is why we design all the different parts of the Plus system that are the dovetail clamp, the dovetail bars. Thank you, Omar. The
put it around
wings,
his neck.
There you go. I'm getting lost with all these parts.
Real quick, Omar, go grab a Vix with the new style Vixens. Dovetail.
Yeah, the new notched rail.
Yes, that's so. This is something relatively new in the telescope field. One of the biggest complaints, in photography is connecting a tripod to a camera and God knows what else. So the photographic world released a standard finally for tripod mounts known as Arco Swiss. So what they went out and did is they went out of their way to create the Vixen dovetail, but they added a twist to it. If you notice, let's put it closer, get it closer to the camera so they can see it. You'll notice that it has the same notches at the top. So if you were to turn it upside down, it now has the Arco Swiss connector that allows you to just slide into any regular tripod that has Arco Swiss, which is actually a huge thing that people have not picked up on. They just thought, oh, they just shaved some edges off of it for fun. No,
and this is in all the different, and this is in all the different lengths of the Vixen style bar. So any of our Vixen style bar now has the Arco Swiss type on the other side.
Yep. So that's like a huge thing. If you're not necessarily doing astronomy, but you're doing terrestrial setups, this system is absolutely ideal when you use the Arco Swiss system with an existing tilt pan tripod. So kind of like this camera that I'm using right now is on a ball head that has Arco Swiss. Strangely enough, I do put the Vixen dovetails on this thing depending on my setup. In fact, even as a regular photographer, I still use the Primaluce Vixen bars because of the different lengths, and I can do different types of setups depending on what I'm doing. So I can build other crazy rigs. So you've got to remember, Primaluce Labs, before we finish, Primaluce Labs is not just your average telescope manufacturing gadget company. these are real users. Filippo is actually an astronomer. In fact, if you didn't notice, he's got dishes.
Omar also. Huh? Omar.
Well, yeah, no, Omar, yeah, exactly. But so you got to understand, you probably noticed that as we walk through the warehouse, there are these great big satellite dishes, so to speak. They're not satellite dishes. They're actually radio antennas, which we're going to bring you back to do radio astronomy at some point.
Yeah.
So you know that Filippo actually is an end user, which is more important. Just like Tom's an end user, just like I'm an end user. We all use these things. And that is what Primaluce has been about, producing products that we can use.
If it works for me, it will work for you.
Exactly.
Before I joined the company, they were so receptive to my feedback, and we actually we got some things fixed and improved, and they're always looking to improve things.
Yeah. So to wrap this up, where can we find you guys? What's your website?
Website is www.primalucelab.com.
And then obviously they can email you through there. There is a contact page there. You can get a list of all the dealers out there. Obviously, we are one of the major dealers here in the US. So, you know, of course, you can come to us. We can answer almost everything.
And you have also Tom. That we are going to. An important thing is not only that there is now Tom that can help and support people in US, but we are going to open also a warehouse and a lab in the US. So any type of help that you may need, all the products comes through the US. So it's faster, it's easier. And this way, of course, as soon as I will be able, I want to come to US again. Lastly, I miss my travel to US. But
yeah, I think
as soon as possible.
I think we're all having that same problem. We can't seem to go anywhere, or we can do this virtually, which is great.
Yeah.
So yeah, any last minute comments, anything else that you guys want to show? We've got literally like 5 more minutes left before we have to finish.
Yeah, we can show you the Esatto working. So this is where we test all the Esatto units, and actually Omar is controlling the Esatto with his smartphone. So this is what we call the virtual handpad. So essentially, when we design the Esatto, we don't want to have an external handpad because you already have one in your pocket, that is your smartphone. So in the Esatto and the Sesto Senso 2, what you have is that the Esatto creates a Wi-Fi connection, so you can join your phone, and essentially you can even control it without the need of a computer. And this technology we have both in the Esatto and in the Sesto Senso 2. So this is also to help visual people that wants to take control of their focusing system without the need of a computer. So you can save the position in up to 9 buttons. So for example, you can save the focus position of your camera, of your eyepieces, whatever you want. And you can control the Esatto like having the classic the computer interface like you have here, essentially.
So yeah, just to reiterate that for you guys out there, this is probably a relatively new thing in the astronomy world, is being able to control a focuser with a phone. Whereas traditionally it's done with like the fine focus knobs and so forth and so on. But being able to do the phone, it is quite a revolutionary thing, especially pre-programming with 9 buttons, because if you switch certain eyepieces, you may not be parafocal with certain eyepieces, and that is a big, big plus, is we can create presets. So I can switch from, say, a 20 millimeter, go straight to a 40 millimeter, which is at a different focal point. And for outreach purposes, it actually can be a huge time saver specifically. So for those people out there that do a lot of outreach and they want to be able to experiment and they hate taking eyepieces out, the great thing about having an Esatto like this is I don't have to worry. I can plop the eyepiece in hit the preset, and I know I will be close to focus. And each person that can come along, we can just adjust it slightly. And it's actually quite a revelation. It's quite fun just to play around with it.
Mm-hmm. Yeah, we see people that essentially is taking the idea, is getting the idea, and they say, oh, really? I never thought we could make this without a handpad. Well, your handpad is already in your pocket, most probably. So why not? And essentially, you can control the Esatto in a standard way from a computer that could be an Eagle, or it could be an external Windows computer, a standard one. But you see that this preset were created before on his phone by Omar, and when you connect to the computer, you get the same preset. So this technology allows you to sync all your preset from your computer to your phone. That is this, you see?
Marvelous. All right, guys. Mike Hatley is about to join us any second now, so we have pretty much run out of time. I do appreciate you guys doing this because you guys are actually in Italy, okay? Remember that. These guys are really somewhere else in the world. I'm here in California. Tom is out in San Diego somewhere. So again, Filippo, thank you very much for doing this. I really do appreciate you putting on this show. Tom, thank you for joining us in your busy schedule.
It was really a pleasure and very fun evening.
Yeah, no, it's definitely a lot of fun, and I'm sure you guys are dying to go home and have, time off.
Yeah, finally. Sometimes we have to.
Right. Whereas our day just started. So speaking of just started, I need to take a quick break because I got to go to the bathroom, and I am going to be bringing in Mike Hatley. So we will see you guys back here in about 10-15 minutes. All right. So we'll see you soon. All right. Bye, guys.
Thank you very much. Bye.
All right, guys, we're just having a couple of technical things that we're just trying to fix right this minute. We will be back. It does mean that the timeline is probably going to get pushed by 30 minutes, but that's not the end of the world because, hey, it's a live stream. I'm in control. I can make this last as long as I want. Probably not for your guys' benefit, so I do apologize about that. But we are fixing it feverishly right now because we do want to show you an active demo of what we're demoing. I'm not going to tell you what it is because then it will ruin it. So we'll be right back. All right, guys, welcome back. Do apologize for the delay. My bathroom break took far longer than usual, as they probably would say, but that was not really the case. I now have here somebody from my hometown, essentially, or my home country at the very least, is Mike and Terry from Starlight Express. For those of you who don't or are not familiar with Starlight Express, they actually make a lot of cameras or astronomy cameras, filter wheels, and things like that. And today we're going to be demoing something quite special here that we had the privilege of seeing a couple of previews to, and now we have a working full-on show to go with this. So some of it might be a little bit heavy for you guys, but bear with us. By all means, please ask questions if you don't understand something. So I guess, Mike, do you want to do a quick introduction, and then Terry, you do your introduction? Tell us about yourselves.
Okay.
Sure. So my name is Michael Hattie. I'm the Managing Director of Starlight Express here in the UK. We've been manufacturing and designing CCD cameras for astronomy for over 30 years now. Terry is the principal designer. He's the guy that was all the ideas from the beginning of that over 30 years ago. So we've both been with the company since its inception. So I'll hand over to Terry.
Yeah, hi, thanks, Mike. Yeah, I'm Terry Platt. I've obviously been with Starlight as long as Mike has, since the 1990s. I started out in astronomy many, many years ago in the 60s, playing around with photography and my homemade telescopes. But in the late 80s, I started to experiment with TV cameras on telescopes, and then graduated to CCDs around 1990. And as you can probably remember from adverts of Starlight Express in the past, we've developed CCD cameras and other accessories since then, right up to the current versions, which are essentially the most modern CCDs available currently to the amateur. So essentially, we're designing modern cameras, modern filter wheels, and in this particular case, an up-to-date spectrometer to use with our cameras, or if necessary, with other cameras. So here we are. This is the essential background to my development. Thank you.
So, Mike, obviously we get to see you more often than not, but Terry, this is obviously the first time we've met, and this is probably the first time you've ever done anything like this, I'm assuming.
Yes, you're absolutely right. The first time.
So we'll be gentle with you for sure. So the theme of this particular live stream that we're doing is, it's basically high-end astronomy, for lack of a better description, but at an affordable price. And this is the part about Starlight Express that I have absolutely fallen in love with over the years, is you have actually essentially made the technology affordable to the masses compared to some of the other larger camera manufacturers. And you guys do this in a very, very clever and unique way, is you've opted for the parts system. You don't have like a prefabricated thing with everything built in. Everything is like an added extra, which is fantastic. I love the idea that you have your filter wheel with the built-in off-axis guider, which makes a big, big difference. So let's start off with some of the products on that side of things, Mike, and just give us a quick brief overline of some of these things.
Sure. Okay. So just so happens we have one here. So this is the filter wheel that you mentioned. We have a built-in off-axis guider. It's USB controlled and powered. So you only have one USB cable, no extra power supplies. We have the new blue edition of the Trias Pro cameras now, which we're actually launching at the end of this week. So you're getting a bit of a sneak preview here. So as you can see, it's the same compact cooled CCD camera that we've been making in the Trias package for about the last 5 years or so. The Trias is because we have 3 USB ports on the back. So your guide camera, your filter wheel, and another accessory, maybe your focuser, can all be driven and powered from the back of the main camera. So you only have one USB cable going back from the main imaging setup back through to your computer. So this is actually the new MIDI wheel, which was released a few months ago, and this has 7-position 1¼ inch filters. We also do 7-position 36 unmounted, and 5-position 2-inch and 5-position 50mm unmounted. So different carousels can be fitted inside the same body. The Lodestar X2, which is a very famous guide camera, it's still classed as being the best one on the market, even after all these years. So that just screws on via a C-thread onto the top of the off-axis guider. And the actual great thing about this package is that from the front of the filter wheel to the actual CCD is 55mm, which is spot on for the majority of the focal reducers that are now available for things like refractors and some of the SCTs as well.
Now, I've noticed that the way that you guys designed this is to take the pain out of guessing for back focus and things like that. Do I need to mess around with the focus on the guide camera, or is that preset as well? I mean, is the entire train parafocal? Yeah,
so the great thing about using this setup as it comes, so we actually do this in what we call a combi package. So that is the filter wheel, the main camera, and the Lodestar. I think effectively you get a few $100s off by it's effectively getting the filter wheel free in the package. But the great thing about using the things combined is that they're all parafocal with each other. When you buy a combi package, we actually preset it here in the factory so that it is roughly, I mean, it might be a fraction out, but it's roughly parafocal with the main camera and the guide camera, so that once you've got one of them in focus, the other one's going to be virtually in focus as well. It's very simple to make these parafocal. So this knob here allows you to move the prism in and out, and this one here allows you to slide this up and down the tube, and in doing so you adjust the back focus. So as I say, we preset it so it's almost perfect, but we don't sky test every one of these, unfortunately, because we're here in the UK, and if we sky test all our cameras, we wouldn't actually be able to sell anything because we get too much cloud, unfortunately.
Yeah, I was going to say, is it like it'll never see the light of day? No pun intended.
No.
Now,
that's right.
one thing here is and for as long as I've known you, when I've seen these cameras, is I used to harp on you constantly about a design aspect, and it's when you showed me this, I was like, oh, finally, the fact that it's gone blue. And
Yes.
to some people, this is like, oh yeah, big whoop. It's another camera, but this is actually a big deal because, as far as I'm concerned, you guys listen to all of us out there. It's not just me that has been saying this; it's everybody out there. That's the great thing about your company.
We've had a few dealers that have said to us that do your cameras come in any color other than black? I mean, we've been using black for 30 years, so it's sort of ingrained in us a little bit. But we did listen, and we opted for sort of this nice metallic blue, which is, if you look at our logo, it's actually part of the logo. So there is a reason for going to a blue color, and also red's been done to death. So we wanted something a little bit different.
Right. And again, this is the thing, is the Trieste line itself, and you know, especially with the 694 and the 180, the 814, is you've gone from different iterations. You've gone from the standard version, then you went to the Pro, which was a big update, and now obviously you've gone with, I don't want to call it experimental because it really isn't. This color is here to stay, but now you're dabbling into aesthetics, which is a big thing with some people, which is odd.
Yes, you know, we've been told by a few customers over the years that we really love your cameras and that they perform incredibly well. But it'd be lovely if they were a different color. And you know, we've always seen that as being a little bit odd because you know these things are used at night when it's dark and you can't see that everything looks black. But we do understand that having something different is important to some people. So we have done all of the small Trias range. So that's using all of the Sony based CCDs from the 825 all the way up through to the 834, which is this one here. So this is a 12 megapixel, quite small pixels, only just over 3 micron. So this is great for things like a short focal length refractor. Some of the other features that we have in the camera, they are very, very light. You can, I have been known to actually juggle with cameras before. I shan't do that today because these are actually working ones. But they're only about £1 each. As you can see, they are very, very small, very compact. But the great thing about these is they are very low powered. So they only take about 1.25 amps, 1.5 amps. So if you're using a car battery at a star party or something, these can run all night and maybe even a couple of lights on one charge of the battery. But these actually cool down to about -40 to -45 degrees below ambient, even in this very small package. So we have very, very good cooling systems. So if you can see, I don't know how close you can see, but this vein here, air is drawn into this vein. There is a series of holes that go all the way through the cooler heatsink, and then get that heat is expelled out the back. The chamber itself actually is purged with argon as well. So these are completely hermetically sealed, and we use a fused silica window. So as the body of the camera warms up, the front window warms up slightly to stop dew forming on the front as well, which is a very important thing, especially if you're down in Florida or somewhere nice and moist. And another key feature which other cameras on the market are just starting to come out with, but we've been using it for probably about 10, 12 years now, is this front panel here, this front plate, which has the M42 Pentax thread in, sorry, N42 T-thread, has collimating screws. So you can actually adjust the plate relative to the CCD, so that if you have any collimation issues, you can actually take it out on the camera side rather than having to adjust the actual telescope itself.
Just to go back into the cooling, I didn't know this about the camera, where it would draw the air in, and now I see how critical this actually is. Most traditional designs that I've ever seen has always adopted the standardized heatsink fin and fan scenario. So air is drawn in from the back and pushed out and then out through the fins. You guys are doing it the opposite way.
Yes, it's actually more efficient if you do it the other way around. So the way we're doing it is, so all the heat is generated in the heatsink plate where the coolers are sat. So to increase the surface area at that point, we have holes going through the heat sinks, and we draw air through there and then expel it out. Obviously, the main body itself will warm up as well, which is all part of the heat sinking process. And we do, if you're in a sort of fairly warm environment, we do have an additional fan that sits on the side, which blows air across the body, just to keep the ambient of the body to a certain, an ambient temperature. So that gives you a better differential, but you can use it with or without. And certainly if you're using this without the heat sink, the extra fan, it's great for hyperstar because it's actually smaller than the central obstruction, even on the C6 hyperstar.
Right. So the other interesting thing here is, though, your method in design has eliminated amp glow, which is a critical thing. I mean, you can honestly, I don't remember taking a dark with that camera. for any particular
No,
reason?
Because we're cooling it sort of down to -40, -45 degrees below ambient, we're getting thermal figures, thermal currents of around about 0.001 electron per second, which is incredibly low. So it means that even if you take a 10, 15, 20-minute exposure or even longer, the actual thermal noise is still lower than the read noise or thereabouts. So you don't actually need to take dark frames with these.
And that differs drastically, and we're not going to go into this, with a lot of the CMOS cameras in that capacity, and even over other competitors' version of CCD cameras, because I've noticed that I can have the same chip with a competitor, but I've noticed that your cameras have performed better, especially when it comes down to that real, dark signal area, and it is just not oversaturated with noise, or you get some weird thing happening and that irritating bar that shows up at the bottom from the amp glow. I mean, I haven't experienced that with your cameras at all, which is just absolutely, groundbreaking for all of us out there that do all of this stuff.
Yeah, we don't suffer from amplifier glow on the CCDs, and we also have with the new electronics in the Pro series, we actually have much better read noise figures as well, and the read noise figures are actually getting as good, if not better, than a lot of the CMOS cameras when used. If the CMOS camera is used at unity gain, we're getting read noise figures that are better. Because you're having, because you've got 16-bit data, bigger full well depth, and much lower thermal noise, your dynamic range is significantly better than most CMOS.
Right. But like I said, we're not going to go into a CCD versus CMOS battle, because we don't want to start anything here. So, Terry, what the new exciting product that has a lot of people interested is the spectroscopy side of things. So you've obviously got this thing set up. Now, just to give you guys a quick, brief rundown on some of the existing spectroscopy products, is everything is like a bolt-on added extra. You've got to get this part, you've got to get that part. It's almost like mind-numbingly difficult for somebody to get into it who is at an amateur level. So give us a quick rundown of the physical system, for lack of a better description, while Mike runs around with the camera.
Okay, I think Mike's going to come with the iPad to show the actual spectrometer. But essentially what's happened here is, about 3 or 4 years ago, we designed a spectrometer with the aim of producing one which was completely self-contained. And it was successful, but never really heavily publicized. We regarded it as a sort of an all-around product, and we weren't too sure how well it would be accepted. Since then, we've talked to people about it and discovered that a remote controlled version would be really useful, and certainly at the moment would be ahead of the field. So for the last few months, we've been redeveloping the spectrometer into a remote form. Now, if you can see what's, you got it, Mike? Okay. Essentially, the optical system in the spectrometer is based around a concave grating. You'll probably find that virtually all the current spectrometers on the market use plain gratings with lenses to collimate the beam and refocus the image onto the camera, which works very well, of course. But the lenses add a lot of weight. They absorb UV light, so the spectrometer doesn't work too well into the UV region. And overall, the spectrometers do tend to be rather large. Now, the concave grating idea has been around a long time, but it's always suffered from the problem that it has a lot of astigmatism. You end up with, if you, for instance, try to project a spectrum of a star, it will be stretched vertically into quite a long line due to the astigmatism, which spreads the light out, makes the spectrum dimmer, and obviously rather more difficult to image, even if you use software to sum up all the spread out lines into one, it's still not particularly good. However, Shimadzu, of course, are very famous for their high quality gratings, have developed a concave grating which includes correction for astigmatism. Essentially, the concave mirror is a toroid rather than a sphere, and the toroidal curve is adjusted so that the astigmatism of a tilted grating or tilted concave grating is essentially removed. So if you project a star onto this grating, you do get pretty well a narrow line of light with all the spectral lines visible within it. So it's a very efficient way of producing the spectrum in a very compact format. To get the spectrum, we need a slit. So obviously the spectrometer has a slit built into it. And if I go over the design, obviously the input is at the front end here. We've got a camera lens on at the moment, but that obviously can be a telescope. Behind the camera lens is a beam splitter. Now it's under this cover at the moment. We obviously have to keep the stray light out of that area, so the cover is hiding it from view. But it's a cubic beam splitter which sends 10% of the light sideways into a guide camera. So there's an actual lodestar guide camera built into the side of the spectrometer, picking up the 10% offset from the beam splitter. The opposite side of the beam splitter has a compartment with a reference lamp in it. There's an argon neon discharge lamp in there, and there's also a small filament lamp to provide flat field information. We can switch either of these on and off using our remote control. So you've got an option to produce calibrated spectra from the lamp or to flat field out and just on the grating. The grating itself is on a thin polycarbonate wheel, which is printed in very high definition. The technique used on these wheels is the same as on the optical encoders, and the slit widths can be produced down to only 20 microns wide with very good regularity. So on that wheel, there are 6 slits varying from 20 microns up to a clear aperture of 3 millimeters diameter. And you can select any of those slits using the small stepper motor, which again is controlled by the remote control board. The output from the slit then enters the cavity of the spectrometer, is deflected by a plane mirror, which is purely there to fold up the optics. And the plane mirror projects the light onto the concave grating in this cavity here, which you might just about be able to see. And the concave grating then projects a focused image onto the CCD at the rear of the spectrometer inside the camera cavity. So the focal plane is approximately here. Now you do need to do things like adjusting the focus and adjusting the part of the spectrum you're looking at in a remote spectrometer. So the spectrometer also includes a motor which is at the bottom here. It's possibly visible. There we have the gear which drives a gear ring on a threaded tube which carries the camera. And that allows us to drive the camera backwards and forwards through 2 or 3 millimeters to get fine focus. And then on the side of the spectrometer is another small motor and gearbox which drives a threaded rod, and this operates the slide and allows you to slide the camera along the spectrum from the UV to the infrared. Typical cameras can only see about half the spectrum. The spectrum is around 30 millimeters long in total, and it stretches from about 350 nanometers in the UV right out to something like 900 nanometers in the infrared. A lot of that probably isn't a lot of interest to most users. They're probably more interested in the visible band, but you do have the option of moving it along to any particular point in the spectrum. So that's the essence of the mechanics and the electronics in there. It's all controlled by a small USB driven board here, which contains a hub to drive the spectrometer and the lodestar, so that the lodestar is controlled through the same USB cable. And it also has a small PEC microprocessor, which does all the functions for driving the motors and operating the reference lamps. And this is all controlled by a small dedicated program which comes with the spectrometer and allows you to do all these functions remotely. So if you have this in a remote scope, you can use, say, TeamViewer to operate the program and perform more or less any operation that you'd be likely to need for imaging spectra. So that's the essence of it. I've gone on rather a long time about it. So are there any questions?
So let me make sure I understand this. This is a complete spectroscopy unit. There is nothing else that I need to add to this per se, is there?
No, you just need a camera on the back and the telescope on the front.
And I mean, you guys are using a regular camera lens there by the looks of things, like a screwed mount camera lens.
Yes, it's just handy for test purposes. We can take daylight spectra, for instance, but it will work with almost any optical device that can focus reasonably well on the slit. So you can put it on more or less any telescope.
So now, is the camera a critical part? Because that is one thing that I do get asked quite frequently, and with ON-Semi disappearing from the market, which cameras, or does all the cameras work with it?
Yes, all of our cameras certainly do, because they all have essentially the same focal length, or for back focus distance, around 16 millimeters, which obviously we designed the spectrometer to accommodate. But there is quite a fair adjustment on the focusing. Although I showed the electronic motor-driven part, there is also a lock screw which allows you to drive the focus tube backwards and forwards manually and lock it in place, which also allows you to orient the camera. And that gives you a coarse focusing action to deal with significant differences in depth of field or depth of focus. So most cameras from CMOS right down to perhaps the deeper, larger cameras can be put into focus and operate with it. So the only thing you need is a T-thread adapter to attach it.
Can we see the thing in action?
We can give it a try. I can bring up the control program if I can see what I'm doing on this very fine resolution screen. There we are. This is the actual program that we provide with the spectrometer. You can select obviously any of the slits. It's obviously set to the finest slit at 20 microns at the moment. The focus, you might see this, it's only a very, essentially what we do is very brief bursts on the motors, because you don't want the motor driving all the way to the end and jamming and things of that nature. Generally speaking, if you're doing a focus adjustment or a spectrum adjustment, you only want to move small amounts at a time. You can set up the amount it moves by in an extra menu that's visible on here. If I go over, you can see the setting for the motor operation time. But normally it operates for 1 second at a time. So if I go forward on the focus, you should see the motor going.
Yep, we can hear it as well.
And of course, the backwards as well. Then moving the spectrometer along the focus. And back again. Obviously, turning the lights on and off you can't see anyway, so I can't really demonstrate that, but we have a reference light button and a flat field light button there, which allow you to turn them on and off. I could possibly produce a reference spectrum for you, but it's probably easy just to show you one that's already taken.
Yeah, let's just, yeah.
Wasting time on that. For start, just as whatever's on the screen at the moment is a daylight spectrum taken with a 694 on the spectrometer. This is simply with a camera lens on the front, and it's a 1 second exposure thereabouts. You can see all the sort of major spectral lines in there. There's the sodium doublet, which you can actually see is 2 lines.
Mm-hmm.
They're only about 0.6 nanometers apart, so the resolution is pretty good. There's the hydrogen alpha down here. These are magnesium lines, and I believe iron lines in this region. And I think that's H beta. Essentially, they're the main spectral features of the sun, and quite clearly visible. Now, if I call up one of the stored spectra, let's see if I can find one of them. Okay, there's quite a few odds and ends here that we've taken. These are the argon neon lamp spectrum, just to show you what that looks like. Yeah, I've gone to 100% zoom, so I'll just bring it back in. So there's the argon neon lamp, which shows bright neon lines down in the red. This line is the brightest neon line, somewhere in the region of orange. And then, of course, you have blue lines, mainly from the argon, stretching into the blue and UV part of the spectrum. So that gives you at least a calibration reference. And then if we open something else, here's the red giant Razalgethi, which happens to be very heavily obstructed by titanium dioxide and other element or compounds in its atmosphere. Now, in this spectrum, of course, essentially you're seeing just a line of light because the star itself is imaged as a line. You can make out some features in there. And these tapered areas are the flutings in the spectrum. Now, it's much better to see this in something like RSpec, which of course shows the spectrum itself. So I'll bring up RSpec. And this is Razalgethi in RSpec, the same spectrum as you saw earlier. And you can see the highly fluted spectrum due to the absorption of the compounds in its cool atmosphere. If I load up, let's see, we can find else in there. I'll bring up Vega because that's a nice simple spectrum. Now this is a spectrum of Vega, which of course is a hot blue star and has relatively few features. The strong features here are hydrogen alpha absorption and hydrogen beta absorption. There are other small absorption features, and if you go into the UV, there would be H gamma and H delta further into the UV. But in this visible part, you can only see the alpha and beta. But essentially, it's a blue star, so the spectrum is strongly tilted up towards the blue end of the light curve, and otherwise a relatively featureless spectrum. If I now bring up something which has a bit more detail in it. This is Chelyaq, the binary star, which of course has all sorts of weird and wonderful things in its spectrum. Now this varies from day to day because of the orbital motion of the stars. This particular spectrum was taken when the two stars were more or less turning parallel to us, so that there was very little Doppler shift. You can see down here is helium, then hydrogen alpha, then a very strong helium line in the middle of the spectrum, another helium line here, and then hydrogen beta. Now all these lines change quite dramatically during the orbital period of about 13 days of this binary. And a lot of the spectrum is composed of emissions from a gas cloud, which are basically an accretion ring around the system, which emits light of its own. So that changes dramatically as time goes by too. But one of the things I'm going to try to get with this in the next few days is an image where the two stars are one approaching and one receding. And I should be able to see a doubling of these lines due to the Doppler effect. Now, if we go again to something a little different, this is M57. And M57, of course, being a planetary nebula, has very well-defined spectral lines with very, very little continuum. The continuum actually on this is mostly from twilight. The image was taken just as the sun was beginning to show in the sky, or the twilight was beginning to come up. So there's a little bit of background from daylight. But down at the right-hand end, you can see lines which are primarily due to ionized nitrogen, hydrogen alpha, and I think helium next to it. And then the bright line into green is oxygen 3, the O3 line, which of course is very predominant in many planetary nebulae. I believe the one next to it is hydrogen beta. But essentially, it's mostly nitrogen and oxygen lines and nothing much else in that spectrum. So there's a sample of the sort of things that you can get. I don't know if there's anything else that's possibly worth showing at the moment, but if you have any questions about that, I'll try to answer them.
Yeah, of course. Obviously, there's a slight delay, so we just have to wait for it all to catch up. So tell me a bit about, from a pricing standpoint, because spectroscopy is one of these interesting things where people are afraid of it, and I don't know why. And when they think spectroscopy, they think, well, this is going to be really expensive. So what kind of pricing are we looking at? Because that's essentially the thing, is you guys have made astronomy affordable for everybody?
Yeah, well, obviously pricing is more Michael's field, so I better leave that to him. But we are trying to keep it within the affordable range, certainly.
So we're just waiting for Michael to
Sorry.
flip his camera back around because we've got this
Does it
fantastic
have to
view
run
of
the
the
other way?
lab.
Is that okay?
Yeah.
All right. Trouble is I
Actually,
can't actually see myself. Can you see me now?
Oh yeah,
Yeah,
we can totally see you.
Okay.
We've never actually seen the lab before, so that was kind of fun.
We haven't tied it up, so it's a bit messy. So, the current one, which
real quick. Sorry, do you want to
Sure.
stop the screen share if we're done with that? There's a button that says end screen share at the top. It's like a red button.
Oh, yes, there it goes.
Yeah, there we go.
Okay.
That's better. There we go.
I can see myself now. Okay.
Yeah.
So the current Spectrograph, which was the same physical size, it's just none of the automation side. That I think was around about 3,500 US.
Mhm.
So the automation side, there's actually quite a bit that's gone into it. We haven't got a final price yet, but I'm guessing it's definitely going to be sub 5,000 US. But when you take into account that's your reference lamp, it's also got a flat field lamp in there as well. It's got your auto guider built in, so it really is your complete system for that price. And obviously then something like the 694 is probably, so the Pro 694 camera is probably the optimum camera for doing spectroscopy with that system. Looking at the pixel size, and obviously the sensitivity, it's got a very high QE and very, very low read noise and background noise. So yeah, it's not cheap, but compared to a lot of other ones on the market, you tend to have to buy the Spectrograph and then you spend another $1,000 for the reference lamp, and then you buy another $1,000 or $500 for the guide camera. And so by the time you've added all the other bits up, actually it is a cost-effective solution, and also fully automated.
So that makes basically it's an affordable way of getting into spectroscopy, and especially if you already have the camera, that's a big part of the cost as it is anyway. I mean, I can think of one other company right now, but half the time I'm seeing prices north of $5,000 for a complete system. I mean, it's like closer to 10 sometimes. This is the biggest thing about spectroscopy, is getting people interested into it. And this is the part that, again, scares everybody. Not price, that's besides the point. It's getting people to understand it. What's the purpose of it? So in a roundabout way, how would you explain it to people? Because again, there's a lot of fear of spectroscopy because it's too much science.
It's really very simple when you want to just take spectra. That's, I suppose, is the obvious starting point, that people just want to see spectra of easy objects. And I really hadn't done any spectroscopy at all until I designed this spectrometer. I just knew the basic principles, and that was it. I found that when I put the unit onto, basically, I used the TAC 104 at home to test it. It worked straight away. I had spectra coming in from all the brighter objects with no trouble at all. And all you have to do then is to go onto the web to find reference spectra, to find out what the spectral lines are that you're seeing. And you can deduce quite an amazing amount of information simply by doing that, taking a few spectra and having a look on the web for the information. For instance, there are quite a lot of relatively bright stars, like Cheliac, for instance, and P Cygni, which is a shell star, which is very interesting to observe because that has both emission and absorption lines around it due to an expanding gas shell being effectively blown away from the star and absorbing some of the starlight. And you can see the Doppler shift going on and the changes in the shell quite easily. A lot of the really serious spectroscopy, of course, is done on very much fainter objects. There are a lot of very interesting but usually very faint stars, which people can do really useful scientific studies on. And I confess I haven't tried any serious observations of such objects yet, but that's certainly the next stage for my own education. And I believe that the only requirement there is to simply use much longer exposures. Obviously, a low noise camera helps, but we've got that, so it's the exposure time. The brighter objects, you can get good spectra in a few seconds. You know, it's no problem to get a good spectrum of things like Vega in 1 second. And of course, even M57 is only about 200 or 300 seconds to get a good spectrum. But some of these really interesting stars are probably about magnitude 8, 9, 10, even fainter, and need exposures often of an hour or more. One of the features of the spectrometer, which wasn't really mentioned in my initial discussion, was that the guide camera has the great advantage, but because it's got a very well-defined and very stable relationship to the slit, it means that you can produce an image or a reference grating of this, or a grid reference of the slit actually onto the field of view of the lodestar. PhD2 is very good from this point of view. We discussed this with them a couple of years ago when we did the spectrometer, and they actually added a spectrometer slit feature, which you can move around within the field to center it on the true slit position, and you can enlarge or reduce to match the slit size. So once you've got that set, which you can do fairly easily, we obviously provide a calibration chart with the spectrometer that says where the slit is, but you may need to make fine adjustments once it's on the scope. Once you've found that position and got the star on the right spot on the lodestar, you can then switch PhD's guiding function on, and it'll hold that star dead on the slit for as long as you like. And of course, it doesn't have to be the slit, the star on the slit you guide on. You can guide with any star that shows in the field. So if your object is very faint, you can still select a much brighter guide star, assuming there's one visible, and guide on that. And it'll still keep the faint object in the slit for the spectrometer. So it's a really useful feature. I think it makes it much easier to use the unit.
Can I use color cameras on this unit?
Yeah, certainly. We actually did a lot of our testing with an old M25C camera, which allows you to see most of the spectrum. And of course, you can see it in color, which then makes it easier to identify things. You get used to seeing the lines and know what they are after a time, but in the early stages, it's quite useful to have the color there to see exactly where you are in the spectrum. So yes, color cameras are fine.
So I think here's an odd way of using it is a lot of us who do astrophotography, for example, we shoot nebulas non-stop. Well, most of us do. I don't do as much deep sky stuff as I used to, but if you were to shoot the Orion Nebula, this is the interesting part of it is it's actually a very, very complex nebula system with different bright areas and obviously all the stars. But it's actually even more interesting to see the spectra of the Orion Nebula. And when you kind of scan through the whole thing and you get an idea of what it is that you're actually seeing, because people just see, okay, there's a bit of blue here, there's a bit of pink over there, and you know, this blown out area must be a bunch of stars. But then when you start seeing these lines show up, the spectral lines show up, it starts to give you a really nice idea of what you're really looking at, and it gives perspective. And I think that's what a lot of people are missing when they see a picture. They just see a pretty picture, but they don't realize what's really happening. And spectroscopy is as if you want to get introduced into spectroscopy, for those guys watching out there, this is a really good way of getting into it. If you want to dig into these nebulas and go, what's this made out of? Why is it doing what it's doing? And spectroscopy is that good starting point.
Yes, it is indeed. I did take some images of the Orion Nebula with the old spectrometer, and it's a very fascinating object. And
do you have a picture of it here, by any chance?
Unfortunately, it's not on this computer. I might be able to find one, but
is it on the internet?
I'm not posting anything myself, but I'm sure there are.
I'm going to go see if I can find one real fast.
I mean, what we find is a lot of people get into imaging, especially do a lot of deep sky imaging for a number of years, and then once you've done all the main objects and you've redone them a couple of times, spectroscopy is the sort of natural progression to move from imaging and actually a way of analyzing some of the data that you've been taking for many, many years, and actually going and looking at the objects in a very different way.
Yes, you can actually do useful science, of course, which is a good thing.
So I'm just going to pinch this picture real fast.
Okay.
Desktop, there it is. I just got to make sure this is the right one that I'm looking at, because I've seen several variations of the same thing. Okay, how do I get this to go to my desktop? There it is. All right, so I'm just going to cover up the screen for you guys for a second. You guys won't see it, but people at home will see this. So this is a spectra of the Orion Nebula. So this guy took a picture with his camera. And as you can see, this is the Orion Nebula. So you can see the core is in here, and then you can see the two arms coming out. And then each one of these lines is a representation of all the different bright stars within the area. And then you can see the bands that are split up. So we can clearly see the O3 part of it. We can see the hydrogen alpha part. And it's really fascinating in the sense that now we suddenly get a huge separation between hydrogen alpha and oxygen 3. And it's almost like looking at an image in triband or individual narrow bands, but across a spectral line, and you can see how it's built up and what's actually inside. So don't think that you just saw this tiny little, slit with these lines there. That's all you get to see. When you really point it at a nebula and you get into the spectroscopy, it's actually like, ooh, that's kind of interesting. Why has it done that? So it's a lot of fun. Don't get me wrong. And I think people are just simply afraid of it, and they shouldn't be.
No, there's a thing, like Terry said, there's a lot of real science that can go on, and the more you get into it, there are actually databases that you can upload your findings to, so you can actually contribute to real science that's going on in a lot of the universities. I'm not quite sure of the name of the database. I know Oxford University were doing one, but I think there are several of them that
there's
you can upload your
tons
data.
that I'm aware of. Yeah. I think there was somebody who they were looking for supernovas, but what they really got into was the spectroscopy of the supernova, which is something else, because at the end of the day, we all know that there's going to be hydrogen, but then what happens at that point when you catch that supernova? What other things show up? And that's where it starts getting really fascinating, and you suddenly see all these offshoots going, what the heck is this? And that's when you get into the spectroscopy side of things and you start to learn, oh, when that star blew up, this happened. And again, it's actually quite fun. Yes. I don't know what everybody's definition of fun is these days, but I enjoyed it, don't get me wrong. Sorry, I thought somebody had a question there. They were just saying that they had a storm coming in. They're hoping they're not losing power. So yeah, I hope not. I know that Italy had a thunderstorm a minute ago, so that's quite amusing. Let's go into the different camera types, because this is probably one of those things that come up more often than not for me, is which camera with which scope. So let's cover all the obvious ones. Let's start with the SCTs. It doesn't matter what the size is, 8-inch, 10-inch, 12-inch, and so forth and so on. Which cameras do you recommend specifically for that?
You do have a problem with SCTs that almost invariably they have a relatively long focal length, and that tends to imply a large pixel size as being the optimum. However, you can get away with much smaller pixels given a sensitive camera, so it's not such a fixed feature of the SCT. One of the cameras we always used to recommend was our H16, but the demise of on semis, of course, is making that very difficult to make now. and it's probably just going to disappear. We can't get the chips anymore. The same applies to the H35, which of course was a larger version with slightly larger pixels. So those two cameras are unfortunately disappearing from the market, but were in many ways very good for an SCT with a flat field. Obviously, I have to qualify the fact that you do need a field flattener or a scope which has been designed to give a wide flat field, because both cameras are for relatively large chips. But otherwise, given that the on semis are going, the 694 is probably your best bet for an SCT on the current range.
Yeah, you've also got the 825. That's got a 6.5 micron pixel, so that's only a 1.4 megapixel on a 2/3 inch format chip, but it's got a very high QE. So sort of a starter camera, the 825 would work very well, especially for galaxies. But obviously the 694, the advantage of CCDs is that you are able to bin the pixels on chip. So as Terry was saying, the 694 is a very good versatile camera, because you can bin the pixels 2x2, which take you up to just over 9 micron pixels. So that's perfect for a lot of SCTs. But then you can then take it off and put it on your wide field refractor and use it in full resolution with its 4.5 micron pixels. So it really is a good versatile camera.
So what about the SX46 and the SX56?
Well, they're ideal in many ways for a good flat field scope with a fairly long focal length, but of course they suffer from the same fate as the other on semiconductor chips. So we do have chips and we can manufacture them for a time, but there's a very limited supply.
Yeah, we do have a number of chips for these, but certainly for the 46, we do have quite a reasonable stock of those. So that's still a very good viable option.
Yeah, I think that's always been the biggest fear for everybody, is all these cameras just disappearing. But in reality, I mean, you guys still have some, so it's not like, oh my God, they're gone, that's it, we're never going to come back. What about the people that use Hyperstar? Because that is the big thing, and that is the go-to thing, either the RASA or the Hyperstar 8-inch, 11-inch, 36 centimeters, which is 14 inches. I don't know why they just don't call it a 14-inch.
So for those, we've got the one-shot color. Obviously, one-shot color is a better way of doing Hyperstar imaging, and certainly the 694 is very good for certainly the C14, maybe the C11. But going down to the C11s, 9.25, and the 8, you've got the 814. That one would work, or does work very, very well with the RASA 8-inch. I've actually used it at TSP last year, and we're getting some very good results from that.
Cool. One of the things that I'm going to highlight about these CCD cameras is, the one complaint I've had is, well, why is it only X amount of megapixels? Doesn't that seem a little small compared to a CMOS? And I always turn around and say, yeah, but you're missing something. There is something known as 2X drizzle, which I use extensively all the time. When you're combining 2X drizzle with a CCD camera, the results are actually quite phenomenal. And it almost is like having double the megapixel size. If you're after something from a print standpoint, I always tell people just do 2X drizzle. And in some cases, if you get good clean data, you can go as high as 3 times drizzle. Now, I actually invite some of you people at home to do this, and we will cover this in a future talk, is do 2X drizzle and compare this against the 694. And for those of you who know of my Instagram, will probably know how to get to some of my data that I've put up there with 2 competing cameras. So I've got the 694 versus another camera, and you can download that data, and then you can do the 2X drizzle, and you'll notice how the 2X drizzle is over where the CMOS is. And if you try to 2X drizzle a CMOS camera, it's like, oh my God, what the hell just happened here? and it is horrible. And you kind of get a good idea for that. So do not be fooled by this. Just because it's only X amount of megapixels does not make it a worse image. All that happens is the scale of the framing change, nothing else. That's all it is. But if you do need to go to print, then 2x drizzle is the way to go. Now, I see Losmandy creeping in here because I can see both Brian and Tanya. So I'm going to drag those two in because there is a reason. These guys are obviously here in the US, and Starlight Express actually is working with Losmandy to help distribute Starlight Express. So hello, Tanya. We can't hear you. I can't hear you, Tanya, and I can see Brian's messing around in the background. Oh, here we go.
Oh, hang on.
Hello, Brian.
Hi, sorry.
We can't hear Tanya right this second.
I can, Tanya.
Hi.
Oh, there you go.
Yes. You know me, I'm so bad.
All right, so guys, so Tanya and Brian are down here at the bottom for us, and then we have the two guys. I'm sandwiched inside of here. I feel like I'm going to get beaten up any second now. But so Tanya, just give us a quick rundown that Starlight Express is here in the US, and you guys help service them as well.
We do, yes. We house all of their equipment, the CCD cameras and all their accessories here at Losmandy, and so we distribute to all of their dealers.
So yeah, so it's, even though Starlight Express is based in the United Kingdom, which is where I come from, contrary to the face, it's great to know that you guys have finally made it here to the US to support the US market. And you guys have gained, as far as I'm concerned, you guys have gained so much traction here in the US. And, you know, we're really happy that you guys have made it over here.
Yeah, it's nice to have. Oh, is that Michael? Hi, Michael. I didn't know you were on.
Yeah,
Hi,
you
Tanya.
can. Yeah, you can't. You see him?
We can talk.
Got it. Okay.
Yeah, so the advantage is that we now have a lot of our products held at Losmandy, so that we're able to ship next day from California to our dealers or directly to the customers. So we don't have any issues with having to ship stuff over from the UK. Obviously, we hold a certain amount of stock, so it's not, you know, now and again there's an odd item that we run out of because we've had a run on. But generally speaking, we have at least one of the items in stock most of the time.
Yeah, and for those guys, you know, if you're interested in picking up a camera, again, it's usually a one-day turnaround time. Sometimes I'll go over there personally just to go irritate Scott and Tanya and grab the cameras and bring them over, or they can just be shipped. And of course, we ship anywhere in the United States, and of course worldwide. If you guys are watching from the other side of the planet, which I know some of you are watching from New Zealand and Australia, believe it or not. All right. So the guys from Starlight, thank you very, very much for joining us. This was like a perfect transition into the Losmandy guys. And any last words from you guys?
Just thank you very much for having us. It's been interesting and a privilege to be on your YouTube, and hopefully you've now got some experience about the Spectrograph and our new blue edition of the cameras as well.
Oh, I almost forgot. So we're going to be doing a promo, is that correct?
Yes, I think we are doing a promo with Woodland Hills for the next 48 hours with a number of cameras. Off the top of my head, I can't remember exactly which ones, but it's basically the small, the Trias, the standard black version of the Trias cameras. We have sort of end of line, so you can purchase those at a discount through Woodland Hills. I assume you'll give some reference
there
number or
will
something.
be there'll be a coupon code. You must subscribe to our newsletter or our email blast in order to receive the coupon code. Otherwise, there is no other way to get this. So you have to actually go onto our website and subscribe onto our email blast. The email blast will probably go out on Monday morning. And remember, it's only good for 48 hours, and we do have very limited inventory in that capacity. Now, remember, just because that this is a blowout cell, so to speak, it does not mean you get a lesser camera. These are still the actual Trias Pro 694s. The only difference here is they were the original black cases and not the new blue cases. But of course, if you do want the blue cases, then those are for sale as well.
They're available. We have those in stock in the US already. So
yeah, so they're pretty much good to go. And don't get me wrong, they are very, very different in terms of the design and the actual look of them, because they do look pretty damn cool. But you missed something about the camera, is the laser etched
oh yes,
stuff.
Yeah.
I know that sounds really nerdy, but it is kind of neat to see stuff like that.
All our filter wheels, our guide cameras, all our product now come with laser etched engraving on the serial number and also the product code, and it's the same with the main cameras as well. So they're all individually engraved.
No more sticky labels.
Yeah, no more sticky. Yeah, no more sticky labels. Mine's come off or faded away since then because it's been outdoors so much. Terry, Mike, again, I really do appreciate it. I'd love to have you back on another time when you guys come up with something else that is probably going to make all our jaws drop or make me want to buy one. One of the two.
Okay, Simon, thank you.
All right, guys.
Yeah, thanks so much, Simon. See you soon.
Thank you very much.
Take care, everyone.
Bye, guys.
Yeah.
Bye-bye.
All right, they're going to quickly drop out of the meeting and we shall pretty much start. Unfortunately, we had a couple of issues earlier on, so they kind of got delayed, so we could just pretty much roll right into it. So, Brian, needless to say, for those guys at home, if you do not know who Losmandy are, you probably need your backsides beaten very severely. Losmandy have been around for a very, very long time. In fact, I love to tell this story, and it's great to see Scott's reaction when I say this, is there is a reason why we call it a Losmandy dovetail, and guess where it came from? And these are the people that essentially created that particular standard, because Scott's thing was, he couldn't stand the fact that every time you get a dovetail, it would be slightly wider, slightly thicker, slightly thinner. It's just like, look, guys, just stop with this BS. Let's standardize something. Let's get everything uniform. And that's what he did. Oddly enough, everybody followed him. And it was a lot better than doing the V-style dovetails because of obviously the narrowness. But when you get these big hulking scopes, you need something substantial. So that's basically one of their so-called claim to fames, but what makes them even more famous is their mounts. So, Brian, I believe we're in for a treat today.
Well, I think Tanya's going to start.
Oh, she is? Okay.
If I'm not mistaken.
Hi, everybody. Thanks for being here today. Really appreciate it. Speaking of with Simon bringing up the dovetail plates, Scott did standardize the D series right here. I brought it here because what I'm talking about is some of the accessories that you can buy from Losmandy that optimize your mount. One of them is the dovetail, because it's a very thick, I'm not good with the millimeters, but it's a very thick one. So you're going to eliminate flexure in your OTA on your mount. So that is one of our accessories. A couple of our other accessories is our AC/DC power supply. This is something that we test here, we know it works. So, and we do find that some people are having problems with their Gemini unit, and it's the power getting to the source to really run that to make it the best computer out there, or the best computer, running the best on your mount. Other one is our GPS unit here. So this will put all the date and time, the correct latitude and longitude and date and time. Is that correct, Brian?
Mm-hmm.
Yes.
Okay, it puts all of those in there. So because we do find that some people, they're off, and it's always 15 degrees or whatever, and it's usually always a setting. So if you have the GPS unit, this really eliminates those issues. And then other things that people just like to have is our CKSs. These tighten down the clutch knobs. These are clutch knob sets that can tighten it down. It just helps because it has these ears on it. So it really helps you lock that down.
Especially when you've got great big gloves on.
Exactly. Yeah, it's cold out there at night, you know, so that really does help you get it tightened down. The other one is where people like they lose the screws or whatever when they're putting them in is our AKS, so you don't have to have an Allen wrench, and our TKS, again, so you don't have to have an Allen wrench when you're out in the field. These are very, very popular. These you do not need. None of these accessories you need, but they just help with your mount and you as holding things, everything like that. So those are a couple things that I wanted to show. What else did I want to, is there something else I wanted to talk about, Brian?
Didn't you want to introduce anybody there?
Okay, so I was going to bring my daughter on.
Oh, I see.
Yes, but of course she's like scattered out of here. So I was like, okay, I didn't want to, you know, I didn't want to make it bad. But I just want to tell everybody out there in the astronomy industry and in the community, my daughter now wants to be an astrophysicist. I don't know what she wants to do, but she definitely wants to be in astronomy. So that's what she's going to college for. And it really had to do with me being in this field. It's really, so let's keep it up. I really want more women in the field. Her friend also wants to be in astronomy also. So it's much appreciated with people going out to the clubs and everything like that, because that's how Scott got started. He got started in the Los Angeles Society, and that's what built this company, was that. So it's really important to continue those local societies for all these young astronomers to be.
So is she going to get into astrophotography is a big question.
Maybe.
I hope so.
Yeah.
I mean, look, she's got the mount sorted out, that's for sure.
Yeah, she's got an in with us, that's for sure.
Yeah. So, and then today, Brian's going to be talking about tips and tricks for to optimize your mount to get it to, I think, 0.5 arc seconds. Yes, he's doing this on a Losmandy mount with the Gemini system, which is what we want everybody to buy out there. Please do. But this can apply to all mounts out there. This is basic, great tips and tricks. Is that correct, Brian?
That is pretty close to what I'm going to talk about. Yeah, I changed in the last 10 minutes as I've been editing it, but.
So I will roll it over to you, Brian. I just wanted to give a little bit talk about our accessories and things that we offer out there. So if you have any questions or if you need anything, just call Woodland Hills. They've got it for you.
Yeah.
All right, Brian, have you got a screen share that you're going to do? I've
I do. You know what? I've been doing some trickery with OBS and some other stuff. So look at that. And you can hear me okay, right?
Oh, yeah, we hit crystal clear.
Fabulous. I got this big, I've got the Simon style microphone here. See?
Ooh.
So here's what I wanted to do. And I'm going to switch. Hopefully this is going to work. Am I looking okay too?
Oh, yeah.
All right. So this is my revised and much nicer version of my presentation title because I'm an urban astrophotographer. I'm here in Sherman Oaks in Los Angeles. This is in the valley, the San Fernando Valley. And I can say with reasonable certainty, this is among the worst possible places to do deep space imaging. It's just absolutely horrific. And Simon, who's just up the road from me, maybe I want to say like maybe Woodland Hills is 10 minutes away, isn't much better and possibly could even be worse. But I want to talk about, this presentation is really about practical advice to achieve sub-arc second tracking. And this is not about how to do guiding, because most people know how to do guiding. This is not about how to do periodic error correction. This is not about kind of the things that most people already know. This is the things that I've learned both as an astrophotographer here in Los Angeles in the last 12 years, but also in working with people through Losmandy and their support things. And I'm also a regular contributor at the Open PhD guiding forums, where I see tons and tons and tons of problems and what people are talking about. So this is really what I call tips and tricks for these things that you probably already know what you're doing and maybe very, very close to this, or maybe even doing better than 1 arc second tracking, but it's just not quite there, right? So kind of what do you do now? And these are those tips and tricks. And first, let me just talk a little about why do I, it seems sort of arbitrary maybe, right? Why do I pick sub 1 arc second tracking? Well, first of all, and this is the most important, our goal in doing this is to eliminate tracking performance as the constraint. So a lot of times people are struggling with this notion that regardless of the camera they buy, there's amazing cameras, they buy this amazing telescope, they buy this amazing mount, and yet stars are slightly oblong. You know, sometimes they're streaking, sometimes it works good on one side of the meridian or the other. But if we can get to a point where tracking performance is no longer an issue, then we can really focus on some of these requirements for doing deep space urban astrophotography. And that particular number, 1 arcsecond image scale, is because in many, many, many setups, I want to say probably the majority, unless you are kind of really advanced or you have a telescope that's remotely hosted somewhere, generally speaking, 1 arcsecond is going to equal about 1 pixel. Now, some people may actually be slightly more coarse than this. Some people might be slightly under, but if we can get our tracking performance to essentially be inside of 1 pixel, what that means is you don't have to worry about it anymore, right? Because there's no way that your imaging is going to pick up any of these tracking issues. So even if your image scale is higher than that, you might be doing kind of wide field type stuff, DSLR types of imaging, where maybe your resolution or image scale is 2, 3, 5, 6 arcseconds a pixel. It's still, I call, good astro hygiene, and it's useful because if you develop these types of techniques, it's going to serve you better both in your imaging now and in your future. So personally, I actually have a telescope I'm commissioning down in Chile in the Atacama Desert, and it's I think the resolution there is about 0.5, 0.6 arcseconds per pixel. It's an astonishing telescope. It's an astonishing place. But all the tips and tricks that I figured out doing here became directly applicable for down there. So it's a great to get in the habit of doing these types of things. And as Tanya mentioned, the tips we have, or the tips that I have here, pretty much apply to almost every setup that's out there. So I'm using obviously a Losmandy G11. I use the Starlight Express cameras, actually the Trius Pro. I think they mentioned earlier the 694. It's a fantastic camera. I also have ZWO cameras, and these cameras are both cameras and guide cameras. And I prefer, Optec focusers. But again, this is what I'm talking about is not specific to any brand or, specific product. So this kind of in a nutshell shows my challenges of being an urban astrophotographer. This is a picture I took last night, which was actually pretty exceptional seeing. I think it was kind of around the new moon. This was with a 28 millimeter lens on a Nikon D850. I took 15-second exposure at f2.8, ISO 200, and essentially we just get a big gray blob. It's incredibly bright. There are very few visible stars. And this was shot at the gradient, and I can still, this was shot at the zenith. I can still see there's a gradient in there. So it's kind of from left to right. So there's just a tremendous amount of light pollution and other types of pollution that kind of make itself almost overwhelming. And in particular, not just light pollution, but actual air pollution, which degrades not only the quality of the image, but it tends to get everything kind of a reddish tint. And I, in fact, struggle a lot of times with getting my blue channels or my oxygen 3 images to come through. This is was a picture I took of the comet. This was, I believe, early morning, about 4 a.m. But this is, again, very typical skies that we have. It's extremely red. You can see all of this gobbledygook down here, which essentially is a layer of smog. So, it's definitely challenging. And yet I choose to be here imaging, which is, you might say like, well, why, what are you doing there? And why are you even bothering? Well, it's not easy for me to travel for a variety of reasons. So essentially my nature photography is in fact my driveway, right? It might be your yard, it might be your driveway, but getting out every weekend is just not always an option. So being really, really good in your astro imaging in this type of environment is incredibly beneficial. It's just going to make everything that you do better. Second of all, as I mentioned, light pollution and terrible skies. I mean, I'm pretty sure they need to extend the Bortle scale, but this has got to be 9+. I mean, I can barely see Orion's belt, let alone anything else. As I mentioned, the air pollution creates a lot of filtering, not just in terms of dimming everything, but it actually selectively lets certain types of wavelengths through better. So in fact, if I'm imaging red or hydrogen alpha, I have a much easier time if I'm imaging blue or oxygen 3. And as with all urban situations, trees and houses get in the way. So this means essentially I've got maybe a couple hours around the zenith where I can really effectively image, and that's about it. I don't have 30-degree to 30-degree skies, you know, in terms of the horizon. And as an added challenge, there's a lot of heat distortion that happens. And this is not just, you know, so heat distortion, of course, is when you look across the horizon and you see things sort of waving and moving. Well, this happens over the houses, over the roofs that get very, very hot during the day. It happens around the asphalt. So it's always a big challenge in making sure that things are cool enough around me and not kind of affecting my images. But nonetheless, it is possible to do what I consider to be high quality deep space imaging. And most of these pictures, in fact, probably all of them, were taken with the Trius Pro 694. I just want to kind of show you some examples. That was, I think, the Wizard Nebula. This is the Black Eye Galaxy, all taken from the skies that I just demonstrated to you. This is the Rosette, NGC 2841, an absolutely beautiful galaxy here. This is M81, 82, again, very common types of things. And I'm sorry that it kind of destroyed my JPEG here, but you know, even being able to get in and get some of these details that normally are very difficult to achieve, you know, I've been able to actually do this, you know, from this utterly horrible place. Narrowband as well. This is an SHO image of the Crescent Nebula. This is M13. So again, really getting kind of fine-grained stars and being able to do this type of tracking becomes very important to get these types of images. And even I've been playing a bit with much longer focal lengths. This is a 10-inch RC scope, but this is M102, which is a very tricky target. But you know, I took a shot at it, and I feel pretty good about that. But what does it take to actually pull off these types of images in these skies? And the number one thing is essentially just endless amounts of imaging. I mean, just ungodly amounts. So those images that I showed you range between 30 and 80 hours of total integration time. I mean, it's an astonishing amount of effort. And combined with this notion that we're you know, I have maybe 2.5 hours tops per night on each of these images, you know, we're talking about 2-3 weeks or possibly a month or maybe even a couple seasons to do this, right? So I have to always be imaging. always imaging. And unfortunately, I've got my automation in place. This is not a talk about automation, but there's just there's no substitution for good data. And for me, that's just taking a lot of pictures. So that means,
just out of interest, Brian, I don't know if you're going to cover this part, but how many subs are you taking and what length of exposures? You're saying you're taking like 40+ hours total data. I mean, that's almost ridiculous. None of us get close to that number.
Yeah, and so it's because I have to, not because I want to, right? So in the Atacama Desert, I regularly take images that I would say far surpass these in maybe 2 hours. I mean, it's astonishing how bad these skies are here. But typically, you know, because of my camera and everything, I'll take between either be 5-minute exposures, or in a lot of cases, I'll be taking 10-minute exposures. And this includes broadband, right? I'm talking about red channel, green channel, blue channel. But this is sort of gets to my key about like why it is that I'm talking about tracking, because in order to do 5-minute or 10-minute exposures and do it that consistently and that long and produce images like this, you've got to have incredibly consistent tracking that is not a factor in terms of your images, in terms of, you know, keeping them nice and tight. So what do I mean by this? So this is an example of a tracking session. This is just back on the 19th of this month, so 3 days ago. My average here for the entire night was about 0.6. So I didn't want to say this is a presentation about how to achieve sort of half arc second tracking because there's a lot of factors that go into this. But just for me, this is pretty much where I end up at. And I want to show you, first of all, there are some, blips and bloops that happen. A lot of it has to do around dithering. You see here, my scatter graph is very tight and very circular, right? So I know my stars are going to be round. And both the RA and DEC have roughly equivalent contributions, right? So essentially what that means is not only is it good tracking, but it's nice, consistent, and round tracking. And the consistency here, this is, I'll show you, I have another slide here. I'm shooting M51 just for the heck of it. But you can see these are, the blue dots here show my half flux radius. My last one right here was about 2.23. It's gone down as low as 1.86, but they're all very, very consistent, right? There's a little bloop in the middle. But this is what I mean by tracking is not an issue for me when it comes to doing these images. And when I do that much imaging time for that long of an exposure length, it's not a factor for me in thinking about how to do this. So this essentially, this screen is the enabler for me to do those types of images. And I'm going to talk a little bit about not how to do guiding, but here are some tips that I have around as you're doing guiding, some things to think about, and some other topics as well. So this is an M51 that I'm shooting now. That you saw some of the guiding. This particular shot is 60 frames of 5 minutes each in luminance. And again, it's just really, really noisy, right? And it's just noisy, but that's kind of the nature of it. So I've got quite a ways to go on this. So this is what, about 10 hours. And just to show you, even though my sky quality sucks, I'll just be clear about it, nonetheless, the clarity of what I'm gathering in terms of both the core of M51, I'm picking up the satellite galaxies here. This is IC 4277 and 4278. You can see, in fact, I can see a little bit of a barred structure in there. There's this little one up here. It's not even, doesn't even come up in my plate saw, so I don't know what it is, but clearly there's other satellite galaxies that I can see in these types of images that I'm taking. So if I back up just for a second, yes, these are very, very noisy images, and I have to take a lot more exposures, but the quality and the clarity of the content of these images, I think, is, pretty gosh darn good. And the guiding allows me to do this. This is another one. I don't think you can see this, but this is about 140 to 160 frames of 10 minutes each, spread across probably 2/3 oxygen 3 and 1/3 hydrogen alpha. And of course, you can see the blue is just, you can't really see it that well because blue has a hard time getting through all the pollution. But this is a 400% crop into this image. And what's important here for me is the stars are all round and they're nice and tight, and they have good color rendition, right? Blue stars are blue, the red stars are red, and there's some smatterings of other types of things. But if I can do this for, Simon, so it's 10 minutes, 160 frames, or like, I don't know what that is, 20, 30 hours.
Sorry, what was the math again?
I think this is about 30 hours of integration time. It's roughly about 10 minutes times 160 frames. So maybe you can figure that out.
26 hours.
26 hours. So if I can, at 400% magnification, produce stars like this, again, this is what allows me to just basically sit around and just image all the time and try to collect enough data to create meaningful images. Let me just stop for a second. I just want to see if there's any questions or comments so far, Simon.
I think most of them are gawking over your RMS numbers.
Okay.
Which is no surprise, because that's what the point of this talk is.
Right. So, and this is where we're going to so I just want to sort of show you the reason that I'm doing these things and why it's so important to me for my situation. So I started, like a lot of folks, like I know how to guide, I know how to do, mount corrections. I know how to sort of check my mount and do all these things, but it sometimes just wasn't enough at the start. And kind of, what do I do now? And I just want to remind myself and everybody that if we had a theoretically perfect mount that was perfectly aligned, did perfect tracking, had nothing shifting around, we wouldn't need any of this, right? And of course, that doesn't really exist. But the point is, all of these techniques have to do with compensating for problems with the mount, right? And by mount, I mean everything. I don't mean the actual, just the mount, but I mean the telescope, the mount, the way it's all connected together, the gears and everything inside it. That's what it is. It is not about seeing conditions. It is not about sky conditions. It is not about the moon. It's about the physical equipment we have and compensating for the inaccuracies there. So essentially what I want to talk about are, these are kind of the 4 areas that are always problematic. And these are sort of the 4 targets, are things that we want to do to solve these. The first is sometimes equipment shifts around. So I have kind of an equipment types checklist in some places. Sorry, I'm kind of going from left to right here. Unfortunately, I couldn't figure out how to get that working. But when things move around, it creates problems that may appear as other types of issues, but in fact, they're just equipment shifting around. That's a problem. Sometimes the mount itself, on the second point, is just not properly aligned to the Earth, right? Sort of polar alignment. And so doing polar alignment, doing it well, is absolutely central to being able to get this kind of performance. And there are, of course, mechanical imperfections in all mounts, which we want to look at with a combination of periodic error correction and other types of things. And then guiding, I think a lot of folks think about guiding as kind of like, well, this is the solution that I'm going to start with. In fact, guiding should really be thought of as kind of the catch-all, right? This is the thing that's going to kind of clean up after everything else. And so it's really more of a last-ditch effort to try to clean things up, right? I had a guy just today who has I think it's a very, very high-end mount, but he had some questions about his guiding performance. And it was, he was something like 0.4 arc-second guiding. And, and when I looked at it, in fact, it was so good that there weren't any corrections being issued by PhD. It just was that good. And that goes to show you that by having all these other issues addressed properly, the guiding even is not necessarily required. I mean, for most of us it is, but again, I just want to reinforce that guiding is not the first choice. Guiding is kind of the last choice. Now, there are some other things that are also equally important, but I'm not going to talk about here. Because a lot of times people will confuse these issues with guiding or tracking performance. Telescope collimation, so you might have funky looking stars. You might think it's a result of guiding, but in fact, it's an optical problem. There might be a problem with your optic spacing. There's a lot of reducers that are sold and third-party reducers. If the spacing between the reducer and the camera is not correct, it's going to create a lot of optical problems. There are other issues like aberrations and so forth, coma, particularly with DSLR or I guess camera style lenses that are problematic. And then a lot of times people are shooting targets that frankly are just really, really difficult to shoot. In fact, I had a couple of ones. There was a group in Draco of 3 galaxies that despite 80 hours of imaging, it just looks terrible. And I'm going to give up on it because it's just too faint. So these are things that are important. We're not going to cover them here, but these have caused issues for folks in terms of understanding their tracking performance and maybe being a little bit confused by those. Any questions so far? Great. So let's talk about my my equipment type checklist. These are kind of the main, this is not an exhaustive list. This is more of a practical list of the things that I've seen cause people problems, and it's caused myself problems. First of all, we need a solid surface that doesn't move or settle. Ground and grass is oftentimes really attractive for a lot of reasons, right? It doesn't absorb heat. There's no problems with this.
Hey,
But
real quick, Brian, sorry. On your screen, can you move yourself to the right-hand side of the screen?
oh, you know what? Let me do this. How about that?
Ah, yeah, that works, because you're covering up the bit of text there.
Thank you. And if I do that, just let me know, okay? I'm happy to move things around. So a solid surface. So as much as I love grass and ground, I tend to stay away from that because even if it settles just a hair through the night, it's going to cause issues for your tracking and guiding. The other thing is that with surfaces, a lot of surfaces that you do like, cement, asphalt, things like that, they can retain heat. And as a result, you're starting to try to image, maybe it's early in the night, it's going to create those heat waves and be problematic. So one of the things that I do often, because I image on cement, somewhere around 6, 7 o'clock when it's not too hot, I'm going to take a hose and actually water down my cement around the mount, avoiding all the electronics, so that I can have it cool down the surface quite a bit more. And especially in front of the telescope or wherever I'm imaging. I try to avoid images that are over my house and over the roof that's been sitting there in asphalt tiles baking for the entire day until later in the evening when maybe it's cooled off a little bit. So avoiding those heat waves is really important. The second point here is I need to tighten everything, absolutely everything. In fact, I oftentimes go through this and just double check everything just one more time before I start imaging, because even the smallest change in any of these things can actually impact guiding badly. And I don't just mean in terms of, well, it shifted a little bit and therefore there's one frame that got lost. If something rotates, it's going to affect the guiding performance, and the guider is going to be off by a few degrees, and suddenly your guiding is going to go to hell. And you're not going to be able to figure out why. And in fact, this picture here, this is my primary suspect. This is what I always check, and it always makes me nervous because, these are screw-on pieces. So they have a tendency to unscrew over time for whatever reason. And I'm always double checking them and making sure they're tight because if they do unscrew, and I use you can tell right here, I use an off-axis guider. So this is kind of problematic. But the same thing can happen also for a guide scope or guide camera. If something rotates slightly, that actually has a much more dramatic adverse impact on your guiding than just about anything else that can happen there. The guide scopes themselves, if you're doing a separate guide scope, I used to recommend highly against that. Now I'm kind of like, well, I've seen some good people have some good results. And again, your results, if you get good results, you can't argue with that. But when I see people have problems with guide scope setups, it's usually because the rings, right? The rings that have the 3 screw-in things can sometimes be suspect. Those things can allow your guide scope to shift as you're both slewing around and also just kind of shifting in general. So I wouldn't say like go out and replace it immediately, but if you're having guiding problems and you are using a separate guide scope and they're held on by rings, look really closely at that. And if you can't figure out how to improve those things, you might consider more of a solid mount, like a clamshell style mount. I'm sure Simon and Woodland Hills have tons of options there. In fact, Primaluce, I've used some of their rings and I thought they were great, but a lot of good choices there. Or use an off-axis guider, which essentially does away with the guide scope with a separate guide camera.
Funny thing is, actually, Losmandy does sell a set of guide rings as well that is really good. And
we do.
They even have that weird little adapter that holds the camera as well, which is really nice.
Yeah, so I want to say like guide rings are bad because I actually have a wide field scope with some Losmandy rings on there, and I use a separate guide scope mostly because I had it, not because I chose it. But just tighten them down, and I said, well, let's just see what happens, and it's guiding really well. It's about I consider it wide field, about a 400 millimeter scope. So I don't want to say like guide rings bad, but if you are having an issue with guiding, and particularly if it sort of adjusts through the night, that's one place to look at, right? And you might consider an upgrade, either in terms of a hard mount or an OAG type of approach. Hope that makes sense. And as I mentioned, this imaging chain is really where I see a lot of problems going on. One thing I'll mention, unrelated to tracking and guiding, but for a while I had some real issues with my flats lining up and calibrating my light frames correctly. So like everybody, I have a bunch of dust motes, things like that. And for whatever reason, I was doing my calibrations and they just weren't completely calibrating out the motes. I had like little circles around these motes. And the problem was, I'm going to switch to webcam here. The problem was actually that I took the flat fields, and then as I imaged, things just rotated just slightly. I mean, even a pixel or two, which is hardly anything, caused my flat field images to be slightly off from my actual light frames and cause calibration issues. So this idea of checking your image chain regularly is actually a really good idea, not just for tracking, but also for some of your calibration types of issues. Let me just stop there and see if there's any questions. I don't think there are. It's really pretty straightforward.
Yeah, usually I'll butt in if I see something really good.
Okay, so I'm just gonna look. I'm gonna follow your lead on questions.
Oh yeah, just keep blasting, and if I see something, then I'll just go poof.
Okay. So in terms of polar alignment, so now we're going to move on and talk a little bit about polar alignment. And I'm not going to go through what is polar alignment and how to do it. But in general, if you're doing imaging, deep space imaging, deep sky imaging, objects, so forth, electronic assisted polar alignment, I think right now is essential. Absolutely essential. I don't think you can do it with a polar scope. It's just, that's the nature of things to get it that accurate. And fortunately, there's lots of great options. Of course, we have PolMaster out there, which is a really good way to get quick and fairly accurate polar alignment. SharpCap as an application, I think, is actually a little bit better in terms of getting it a little bit more precise. But sometimes it's a little bit hard to use. And by that, I mean, you have to use your imaging scope, typically with SharpCap. And those tend to be longer focal lengths. So I find it's a combination of having to wait later in the night to get enough stars so that this plate solve is going to work. And then sometimes it will sort of fail, so again, for lack of a better term. It fails on the plate solving until it's so dark that I feel like I've lost maybe 20, 30 minutes of imaging time. So my current favorite, which I only recently found out about, was to use SharpCap for its precision, but to connect it to my PolMaster little device, my little hardware device.
You know, I gotta say this. I'm so glad that you just said that, because I'm not the only person that discovered that trick.
Yeah, and it's again, it's a compromise, right? Because if you're doing SharpCap with your longer imaging scope, it's probably going to be a little bit more precise, but I'm giving up 10, 20, 30 minutes waiting for the skies to be dark enough so that I can get enough stars. And with PolMaster, I find that I can get really pretty close. I want to say within maybe 5 to 10 arc seconds of what I could with my imaging scope. And a lot of times that's a good trade-off to make, right? So I really like that combination. I already own the PolMaster hardware, for the $10 it takes to get the software running with SharpCap. It's a great investment. And by the way, the reverse, right? So if I have SharpCap, PolMaster is a great investment to make, because I can do this much faster, and it's just a lot more convenient to do that.
I do want to add something to this, though. I have an Esprit 150. So I've already got 1000mm something odd focal length, and I still use SharpCap to do the polar alignment. If you're in a situation where you do use a longer focal length scope, do not try and do a polar alignment with something with a shorter focal length, because it'll actually give you a less favorable result, strangely enough. So if you can do it with the native focal length, it's actually better.
Right. So that's a trade-off, right? And I tend to agree because I have the Esprit 120 and I've got another one, the 130. What I found is if you absolutely, if I have a time, maybe if I have something I've set up and done for a few, I expect to be running it for a few days or a few weeks, I absolutely do what you're describing, right? The trade-off using PoleMaster is it's really not that more inaccurate. It's certainly you can do better with just native sharp cap, but I just want to say this is a good kind of interim that will get you faster and pretty close, right? Everything is a bit of a trade-off. With regard to polar alignment, so the actual process of polar alignment. So, in other words, now that you've got whatever you're using, PoleMaster, sharp cap, even if you're doing your polar scope, you're going to actually make physical adjustments to your mount. You're going to change the altitude. You're going to change, and of course, this is a Losmandy mount. I've been experimenting with different types of things. Tanya mentioned we have some thumb screws in here, which Losmandy hasn't seen fit to give me some. So hopefully they'll see this and want to give me some. But
you already just work for them. You could just go and rob the place.
Well, I want to kind of encourage them, right? Just be like, hey, you guys, look at my mount. Maybe think about giving me some of these types of things. It'll be good. It'll be okay. But in this process of loosening, because you have some bolts that are going to tighten everything down, right? So here on this Losmandy mount, here's the altitude bolt. Here's the altitude adjustment. Here, there's one on each side. This is the azimuth tightening down, and this is the azimuth adjustment. A lot of people think that the way to do this, let me do this, is to loosen everything, do your adjustments till you get it just right, and then tighten it down. And that is 100% the wrong way to do that, because there is a lot of slop that are in these mounts. Even with a high-end astrophysics mount, there isn't. But for these, there's backlash, right? So if you change direction, you're going to move it and nothing's going to happen. Then you're going to move it again, then it starts to move again. And of course, you change direction, it's going to happen again. The way that these are designed to do accurate polar alignment is an iterative approach. So what you do is you loosen them, and then you snug up both axes so you can still make the adjustments, but they're not completely loose. And as you are adjusting at the altitude and the azimuth, you adjust a little bit and then you tighten them down a little bit. And then you adjust them a little bit and then you tighten them down a little bit. And you go through an iterative process. And that's going to give you, at the end of this, the best and most accurate polar alignment that's not going to be jerked out of alignment because you decided to just crank everything down at the very end. The second thing I want to mention about this is that I mentioned this specifically for altitude, which is especially true, but this is also true for azimuth. You generally want to go in one direction. So essentially detune them both in one direction and then tighten them up. Like for the altitude, you want to have it be going up. So I go too low and then I slowly move it up and I try not to reverse the direction. And that tends to make not only the polar alignment more accurate, but it tends to keep it there much more accurately. And that's something that a lot of people don't quite understand the nuance of how to use these systems. But I think if they adopt both the iterative approach and the single direction approach, it's going to help a lot in terms of the final polar alignment.
I'm going to mention something about the up-down or altitude part of it. Is there is a reason why what Brian is saying is if you need to let the mount come downwards, you have to remember there is more weight pressing downwards on onto the tripod. And when you adjust a drop, you'll notice this big movement as opposed to you moving upwards because you're fighting against the weight, which is why it feels smoother. Right. And more often than not, I mean, I'm using an EQ8 RH Pro with God knows what on it. And if I have a 12-inch Quattro on there, it's torture doing polar alignment when I'm lowering it. But I found going upwards is way better than trying to lower it. So always aim slightly higher. Always aim lower.
Adjust up, right?
Adjust upwards.
Right. And again, I think that's true of the azimuth. So for me, I move it all the way to the left and then start rotating it back. Well, I should say left, I should say move it all the way west and start to rotate it east. But again, that's just, I mean, the goal here is these are just small things that will make your polar alignment more accurate, and it's a little bit of clarity on how these mounts are designed to be used. And I think that, as you pointed out, Simon, it's true for pretty much every mount, right? It's not just a Losmandy mount.
Every mount has that same problem. Some are way worse than others. Some have like these fancy newfangled designs, but they all suffer from the same problem: downwards force.
Right. You can't escape gravity, right?
Well, get high enough and it might be a different story.
Let me know when you get there, okay?
Yep. You know what? That will be the day I could just leave a telescope pointed in one direction. It will never move.
Right. I should probably say this is all for terrestrial telescopes, right? Because obviously if you're in space, it's a whole different set of issues that come into play. But okay, so that's kind of my polar alignment tip. So when I do this approach, in my telescope, I tend to leave set up in my driveway for weeks or months at a time. This allows me to feel confident, and I've been doing this now for about 2 years continuously. I feel confident that I can recheck my polar alignment every few weeks, not every night. But if I'm having to break down and set up again, like in the last few nights, I've been shooting Neowise, the comet that's been is in the backdrop here. I've actually taken my mount out into the field and then come back and set it up for imaging again. I'm going to double check, obviously, my polar alignment. So let's talk a little bit about periodic error correction. So as we talked about before, the purpose of all these tools is to essentially compensate for the mount and the tracking. So all mounts have a certain amount of periodic error in them. Some are higher than others, but they all exist. So if we're talking about how do we use strategies and tools for offsetting that periodic error, then clearly knowing your mount periodic error is going to be very valuable. You can look at it and actually make some, data-based decisions rather than just kind of running tools and hoping it's going to do okay. If you want to understand your periodic error, there's a very easy and essentially free way to go about doing this. And Simon, I sent you a couple links if you want to put these into the comments field.
Yep.
But in PhD, you can run it, and there's a tool called Guiding Assistant. The tool is designed primarily to help you evaluate the seeing for that night and determine the min moves. But when you're in the Guiding Assistant, essentially it's tracking and outputting it's tracking and recording unguided output. And you can use this if you do this for 4 or 5 worm cycles or more. So that's, for most of us, that's probably 30 minutes to 60 minutes. You can take that information and you can actually open it up in the PemPro log viewer. It's a free utility that Ray Graylack, who is the author of PemPro, has provided. And as I mentioned, I think Simon just put the links in for both of these. Great, thank you, Simon. And this is going to give you a very clear and data-driven approach to understand what your mount's periodic error is. And if you need to reduce your periodic error, it's a good thing because that means that there's less work for the guiding to do and it results in increased opportunity for precision. So for example, this is my mount. This is a stock G11. The only important stuff I want to point out here is this is the primary periodic error of my mount. It's about plus or minus, but actually it's plus or minus maybe 2.5, 2 3/4 arc seconds. And then I have a secondary, which is much lower. And I have a third, a tertiary, which is somewhere out here. It's maybe like 7x. That's much lower. But you can see that clearly this number is much higher and much more prominent than everything else. After doing a periodic error correction, I use PemPro for the Losmandy mounts. There's lots of options out there for different kinds of mounts. I think PEC Prep is for the EQ mod type mounts. Here's my after. And I'm not aiming for perfection. I'm aiming for better than. And I think you can see that here my primary periodic error, I'm just going to kind of go back and forth. So the primary has gone from, plus or minus, let's call it 2.5-ish, down to plus or minus, say, 1 1/4-ish. And that's pretty substantial, which is going to make my guiding easier and what's going to make my imaging better just by virtue of employing this, sort of mount-based periodic error correction. In addition, you can see in my secondary one here, it's dropped down. Well, I can't, it's behind my camera here. So it's gone from ±1 to plus or minus maybe half. So it's not just the first one, but also the second error, primary error. They call it the harmonics of the primary error that are actually being reduced down. The third one, it doesn't really change that much, but that's okay because now I start to focus on guiding as the way to start thinking about this residual errors and how to get rid of more of these types of things. So my goal is not to describe periodic error correction, but just to show the benefits of something. This was a relatively simple approach on how to do it with a Losmandy mount.
Before we tick over, periodic error is one of these things that kind of scares people and they're not overly familiar. And in fact, a lot of the times I've seen people do PEC in general make things worse.
Yes.
So I know we need to probably a talk on just PEC alone at some point in time, but just give us a quick overview of some of the common mistakes that everybody makes so they know at least where to look at. Otherwise, they'll download the program, they'll run the PEC, and then they'll go, okay, upload, and not realize they're not uploading anything, and they're just putting an error back into it.
Right. So, Simon, that's a great point, and I want to sort of re-emphasize this for a second. Bad periodic error correction is worse than no correction at all. You're going to make your mount perform worse. So my first bit of advice is, if you don't know what you're doing and are not prepared to spend a good amount of time figuring it out, and the good news is you only have to do it once, but if you're not prepared to spend some time, don't do it. Just don't do it, because the chance of you making it worse are very, very high. Now, let me back up here for a second on this. The suggestion I have here is just to measure it. Okay, and I think that's a really important step that everybody can do. They can do it for free and they can do it without any danger. But once they understand it, at that point, they can decide whether or not it's worth investing the time. For some of these mounts that maybe have, absolute encoders involved in them, things like that, it's less important. And they might do this thing and say, hey, it's, my periodic error is ±1. I'd say it's probably not worth you doing any sort of periodic error correction. In fact, you shouldn't do that for absolute encoders. But this idea of just being able to get this data, open it up in Pen Pro, take a look at it, is a free and safe way to figure that out. The challenges of going through a periodic error correction is just there's too many to talk about right now. The good news is we're actually developing a multi-part tutorial on this, Simon. We're actually in part 3 of maybe about 7 parts that go through great detail. So maybe next time when we do a Woodland Hills Telescope presentation, we can actually talk in some detail about periodic error correction, because it is scary, but it turns out it's really not that scary after all, right? It's fear is the only thing we actually have to be scared about.
I think the fear is the software, because I've tried to walk people through this and they just cannot grasp the concept of it, and they think they press a button and magic elves come out of nowhere and fix your mount for you. I know you're transitioning into guiding now, so I may as well mention this right now. This is the most common thing I've heard, and I've heard it to death, and I want to clock everybody who says this. You can't use PEC with guiding. Yes, you can.
That is true. Now, I will tell you where that came from. There was a bug in somebody's software, not Losmandy.
No, we're not going to name names.
We're not going to name names, but for whatever reason, that particular bug, and it was a popular mount, caused issues between the periodic error correction and the guiding, such that you couldn't use guiding. And that was actually that particular mount company said as much. And there was a period of, I want to say a few months where it, obviously that got around and it was really concerning and confusing. Generally speaking, though, you're absolutely right. Periodic error correction that's in the mount that offsets the periodic error of the mount and guiding are designed to work together. In fact, that's kind of my point here, is that if the whole goal of this exercise is to make the mount work better, I guess more specifically to offset the problems of the mount with software, then clearly you want to make the mount perform as best as you can. And then guiding is really kind of cleaning up the residual type of stuff.
So yeah, I definitely am one of these advocates in that sense that don't look at guiding as the be all and end all. I know you're going to get into that next. Guiding is just that. It is there to assist any residual errors. There is nothing that can replace a good polar alignment. There is nothing that replaces a good periodic error in terms of an adjustment, because let's face it, if your mount has a blip, you've got to get rid of that blip before you worry about guiding, because the blip would have happened, but the guiding will not catch up and it's not going to know, and then you're just going to get this erratic movement of it trying to correct.
Right. So I analyze about 30 guide logs a day in the Open PhD forums, just as a way to help out. There are situations where there are clearly mechanical problems in the mount that actually cannot be guided out. Mounts, it's got some sort of blip in it, as you described. Who knows what it is? But guiding can't solve all problems, right? Guiding is really the cleanup guy, right? It's like whatever's left over after you've done all this other work, guiding is here to sort of make it all kind of smooth all over, right? It's the fixer, right? But it is not the primary tool in how to go about getting this excellent tracking.
All right, let's move on before we start something here, because this will be an endless debate.
Okay. So, kind of building on that, guiding is a companion in many ways to periodic error correction. It's what I call the leftover error. So if we back up for a second and I mentioned, this is the leftover error. There's not zero error. There's clearly some error left. It's less than before, but it is much smaller. Here's our friend guiding to help it out. And one of the things that I really like about PhD2 is it's had for probably the last year or two a new algorithm, relatively new, called predictive PEC. And essentially what this algorithm is not the default. So you have to actually go in and select it. And you type in your mount's worm period, your primary period. So for a G11, for a Losmandy G11, that's 239 seconds. And what it does is, essentially this algorithm is a combination of predicting periodic error and hysteresis, which is the normal type of periodicity. It's a normal type of reaction, which just, hysteresis, it looks at the history and says, okay, well, I've seen these types of changes, so I'm going to assume that these are the type of corrections I need to make. But what it does is it will run through one cycle of your worm, and then based on what it sees as consistent changes that it sees every single time, it will predict that there's going to be a period error and make an adjustment in advance of actually seeing that. And if you think about it, that is essentially what periodic error correction does. It's just doing it in an algorithmic way rather than a pre-programmatic in the mount way. Conceptually, maybe that's a little too much to swallow all together, but conceptually, hopefully people understand that these two ideas are very powerful together, that if we're trying to account for the inaccuracies of the mount, we've got PEC as our primary, and now we've got predictive PEC as the secondary. These two things work really, really well together and can get you this type of guiding results. The second thing I'll mention is it can target periods other than the primary mount, other than the primary periodic error of your mount. I had a mount, it was a G11T, and I was able, with my periodic error correction, to reduce the primary period low enough that it became essentially a non-issue. But there was a 39 or 40 second error that was actually ended up being higher than my primary period. So what I did was I use periodic error correction to reduce my primary. Then with predictive PEC, I set the period at 40 seconds. And I think the guiding, the exposure time was 1 second because I needed to be fairly reactive. So it was a little bit of a trade-off in terms of seeing. But essentially, I was hammering at that 40 seconds, right? So here's periodic error correction, the in-mount stuff, handling the primary period, and then predictive PEC and guiding, hammering this secondary. And the result was a great combination that worked well together. And the point here is I want to show that this notion that mount-based periodic error correction and guiding algorithms are designed to work together, right? They think about, well, you should think about them as being friends, and they should know about each other. At least you should inform the way that you use them, knowing about each of them.
Question. What exactly is PEC doing? Is a question that I just got from somebody. So do you want to describe it or shall I?
You want to give it a shot?
Okay, so what PEC actually is, if you can imagine the worm gear moving, okay? If it comes into a situation where it takes longer to get past one particular point, what PEC does is tells the mount to either speed up or slow down, depending on what the problem actually is. So if you can imagine a line, and we've got these problematic areas that show up, when it gets that point, the mount will either speed up or slow down in order to get rid of that problem. So that's essentially what PEC is actually doing. So remember, It's got nothing to do with guiding. It's got nothing to do with accuracy or any of that stuff. It just tells the mount to speed up or slow down in certain situations. Now, it does not accommodate for backlash. So don't move your mount in such a way and start trying to record a PEC while it tries to catch up with the backlash. Otherwise, you'll end up putting that backlash, the opposite, into your PEC graph, which will show up as a huge, horrible spike. So remember to make sure that your mount comes back into the position where it is actually engaged, the mesh or the teeth are actually engaged, then run the PEC. There's another part of hysteresis, which, since we're talking about that PEC side of things, is you have to let hysteresis run its course. Do not just start it and start guiding and start doing a correction and all this, that, and the other. Hysteresis is a word meaning history.
Right.
It looks back. So you have to have data to begin with before you can run an analysis. And that is a common mistake. I've seen people who run PEC too quickly before hysteresis has enough data to look back at what's actually going on.
There was a great, so Bruce Waddington, who is the author, one of the authors.
He was on last time, just so you know.
I know that. And by the way, I had a bet with him that he wouldn't say the word, I forget what it was, but it was when pigs can fly or something. I said, I bet you won't say that in the presentation. And he did. And I owed him something for that.
Yeah, he did say that.
But if you can put a link into his presentation in the description maybe of this video, it's a great presentation. I mean, he is so articulate and clear about how guiding works. I mean, he's one of the absolute foremost experts on guiding and how to get it to work. And I would really encourage people to watch that one as well on your channel, right?
Yep. It's in the replay section.
Great. So let me just kind of continue on because I think we're a few minutes over already, but I'm almost done. One of the other common things I've seen that people do is around dithering, and they have extremely aggressive dither settings or sort of very difficult settle times. And without getting into a lot of detail, you don't need a tremendous amount of, dithering is the process by which you instruct the guide camera to sort of move the guide star by a certain number of pixels to avoid fixed pattern noise in your sensor, right? So if you have a hot pixel, if you move the hot pixel around enough, it is going to disappear in your integration times. So a lot of people get very, very aggressive about their dithering. So they move it by 10 pixels, 15 pixels, and they have these tremendously difficult settling times. Like I want it to be under 1 pixel for 30 seconds. And I have seen guide logs, especially with these CMOS cameras, where people are imaging very, very short time periods of 30 seconds, 60 seconds, where a good half of their imaging night is taken up by settling. It is not needed. So when you're doing guiding, please use the log viewer and look at that. When you bring up your guide logs, it will show you how much settling time is involved. And if you find it's a tremendous amount, your chances are your settle times or your settle criteria, I should say, is way, way too conservative. So that's something definitely to look at as well.
Okay, we got a question here, and I knew somebody was going to ask this. When it comes to load on RA worm gear / belts, is it best to be a tiny bit top or low heavy or balanced at 50-50? We're talking about counterweight balance on the mount.
Right. So RA balance. So with Losmandy mounts, because we have, we have a spring-loaded worm, which is I think other folks do, but I know that Losmandy mounts does. We actually rely on the spring for the contact between the worm and the worm gear. So in our case, we want to balance it pretty much equally. For a lot of other mounts, you want to essentially bias it east. You want to bias the weight east just a little bit. You don't want to do it hard. And the reason why is because RA is always rotating in the same direction. So you want these teeth, to be engaged. And if you then go to the opposite side of pier, now you're imaging with pier side west and imaging pier side east, pier side west, you're still going to want those gears engaged. And therefore, if you have a mount where you do need to bias the weight slightly, if you flip to opposite side of pier, you're going to need to adjust that weight slightly. Sometimes what people will do is they'll have like a little kind of add-on weight. I probably have one around here, but they'll balance it slightly east heavy with pier side west, so you're imaging east. And then when they do the flip, they'll actually just take that weight off. And what happens is it ends up still being east side heavy, but now the telescope part of it is going to be the heavier side. But you always want it to be slightly east heavy because that's the direction that the RA is moving in, and that's how you keep the gears engaged, the RA gears.
But obviously with the Losmandy mount, that is not overly essential because of the spring-loaded worm block.
Right. In fact, our recommendation, since the spring-loaded worms, which is a standard, it's a standard accessory that comes with the mount, we have them balance it neutral because that spring is actually taking care of making sure that those the worm and the worm gear is engaged at all times.
Oh, and just to add, if you guys do have a G11, and I get this at the store, yes, we can do upgrades to replace the worm block as long as you have all the necessary parts. I think Tanya will talk about that later on when we get to the end of this presentation.
Okay, but yes, we do. Tanya, by the way, you're muted, but we do provide upgrades. I think we've upgraded mounts as old as in the 1990s and brought them up to spec if people want us to do that.
Yeah, that is true. You can do it from any of the G11s that have been made or the GM8s, any of those. It's most effective on the G11s just because if you do it on a GM8, you're almost going to be buying a whole new system anyways, so just buy a new mount at that point because it does cost a little bit, but some people are partial to their mounts, but you can bring it up to the current version, which is nice.
Right. So that's a cool thing about Losmandy. Basically, we have the ability to get the latest mount from any mount that you've bought previously. Let me also talk a little bit about backlash because this is probably the #1 thing that is vexing people and confusing people. They think they've measured deck backlash and it's going to be a big issue. And in fact, there was a feature in PhD that talked about saying your calibration succeeded, but there was little southern movement, couldn't establish backlash criteria. And it was causing so much confusion because it wasn't an error, it was an advisory. But it was causing so much confusion, they actually removed it from the latest release because it was confusing. So the point I want to make about specifically deck backlash, which is the only type of backlash that we think about. Backlash itself is not a bad thing. We need that because temperatures change, because gears have to mesh. What's bad is unmanaged backlash, right? Things that cannot be effectively guided out. And PhD in particular has an absolutely astonishing and good auto backlash compensation algorithm. All you have to do is just turn it on. Like literally all you have to do is turn it on, and it adjusts itself through the night as it's watching the deck backlash, and will figure out the right amount of backlash to use to ensure that your deck is operating well within the kind of tracking well. So it's backlash is not bad. It's expected. In fact, if you were to actually go back and look at my original diagrams from my very, very low tracking results, you would see there's tons of backlash going on, but it's compensating for it extremely well. And oftentimes deck is the least of my concerns when it comes to the actual numbers. So I just want to make a plug there for auto deck backlash compensation. It's a fantastic tool. Don't get weirded out by things that it's saying in terms of like, I can't measure the southern movement. And in fact, so this is another link I sent you, Simon. Hopefully you can drop this into the comments. As part of my work with the Open PhD contribution, I put together what I call a baseline guiding, guide to baseline guiding, but essentially describes how you can go from just starting, get the software up and running, and set up your mount in a certain way and calibrate it in a certain way and gather this information in a certain way that will give you what I would call a baseline guiding and avoid the most common issues that people run into, of which, backlash is certainly one of them. So it's a great place to start. Or even if you've done guiding for a while and you're just not sure, how your numbers are looking, it's a great place to actually start out and sort of get yourself a solid baseline to guiding. Last thing I'll mention about guiding tips. A lot of people fiddle with things. They fiddle with the aggressiveness, right? It's going from 0.4 to 0.45, 0.5. And we just see this endless small little set of increments about these types of changes. I promise you those don't do hardly anything. They are not going to make much of a difference. It's tempting to fiddle with them. But the most important things in guiding are good, solid calibration, getting auto backlash compensation, working if you need it, and using a good guiding algorithm like predictive PEC. And all those other small things, they're probably, they're really not going to make that much of a difference. It's the big things that are really going to actually cause you to go in there and get some of those good results. So in my guiding results, I have never, ever gone in and adjusted my aggressiveness on either my deck or my RA. It's all these other things that we've talked about in this presentation, thinking about polar alignment, thinking about tightening things down, thinking about the correct algorithms, things like that, that make the difference in terms of getting these types of numbers.
I've got to say this. When Bruce was doing his thing, that was one of my biggest pet peeves. Is I've seen people continuously mess with the hysteresis number, not knowing what that means, the aggressiveness, the minimum, maximum movement. And I keep saying, look, there is an icon there, which what we refer to as the brain icon, that figures all of this stuff out for you. And you should not have to mess with it. And I see on a regular basis on YouTube tutorial videos on how to fine-tune PhD2 settings. And I am literally like flipping around on my chair trying to punch the person across the internet, because it's like, do not show people this. This is the cause of half these problems. And I've seen people dial in these BS numbers to where the graph is almost like solid and doesn't have any spikes. I'm like, dude, what you've just essentially done there is told the pixel scale has gone from this to this. So the error of looking for that movement is now inside of this box that is so goddamn big that it doesn't see it.
If you zoom out far enough, everything's going to look flat, right?
Right. And, there is no error there all of a sudden. I said, leave it alone. Get these problems dealt with before you work about this problem. And even if you had that, don't touch it. And that was one of the things that me and Bruce were trying to iron out during our talk.
So Simon, by the way, you seem to want to punch people a lot through the internet. So you might want to get some anger management there.
Do you know why? Because I get a lot of phone calls at the store with people with these types of questions
Sure.
and these comments. And I keep saying this, I don't know where you get your information from, but the idea behind this is we're trying to make this thing simplified, but there are people out there who want to complicate it, and I don't know why. And I wish these videos would just go away. You know, the misinformation about PEC with guiding has been the biggest bane of my life. And somebody will always go, well, it says on cloudy nights that blah, 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 blah.
Right.
I'm like, oh, great, here we go again. You know?
It's we're a fiddly bunch, right? We want to fiddle with stuff. We like the idea that we have complete control over. You know, we live in a world right now where we don't seem to have a lot of control over everything. Mm-hmm. But I'll tell you, astrophotography, you can type in numbers all night long and fiddle with it. But it's kind of the nature of who we are and why we're attracted to this kind of thing. But you're absolutely right. And again, I want to emphasize, like, fiddling with those numbers is really probably in the end not going to make that much difference.
You know, if you're into statistics and you're a number crunching guy and you don't want to do astrophotography, knock yourself out. You know, it's fun to watch mechanics if that's your thing, because I do know people that are really into mechanical motion and measuring all these weird and wonderful things because they like to see this.
Right.
But I'm not into that. I'm trying to take a picture. So my thing here is I do need it simplified. I do want to be quick and easy about it. But it's crazy how people miss these fundamental things. And again, I do want you guys who are watching this to go back and rewatch some of this stuff so you get the point. Guiding is not the be-all and end-all. You still have to cover all the other major points that Brian has gone through. And this is not just with, you know, one particular mount. This is any mount that you might buy, even the high-end ones.
Right. So let me try to finish this up. I know we're running a little bit over.
No, you guys are last anyway, so we can run over by an hour for all I care.
Okay, well, if you set up every night, right? So if you tear down and set up, I really encourage you to take the time to recalibrate your guiding. I mean, it's kind of a pain in the butt, I know, but even small shifts make a difference, even if it's just, and again, the angular part is really what sometimes is an issue. So if you have a guide scope and it rotates just slightly, that's going to cause your guiding to be off and you're going to get poor guiding corrections. So if you're resetting up, just take a quick moment, recalibrate your guiding, you'll be in good shape. Related to that, Google celestial coordinates and learn about where is the intersection of the meridian and the celestial equator. A lot of people think that deck 0 equals like altitude 0 or equals the zenith, and it doesn't. And I don't want to get into a big discussion of kind of what that is, but if you Google celestial coordinate system, there's a lot of great material out there, and you'll realize that there is a very specific place that's specific to you about where this intersection is. And the reason we want to go there is because that's where the most of the star motion is. So that's where you're going to get the most accurate calibration. So I'm done. I hope that those sort of tips talking about the things that you probably already do, but maybe do them a little bit differently, are going to help kind of give you that little bit of an extra edge to get yourself to the point where tracking is not the constraint, right? Which is sort of always my goal, and I think always the goal of a lot of folks, is they just don't want to think about the mount and what it's doing.
So sidebar here, last live stream we talked about was about Alpaca. And I remember we had a brief conversation and you mentioned that you guys are close to becoming Alpaca ready, or you are Alpaca ready.
Yeah, as of I think about a year ago, our current ASCOM driver version is 1.0.75, which is available through our website. I'm sorry. If you get the ASCOM driver, go to the ASCOM standards website, and if you go under mounts, our latest version is going to be there. That's the official distribution. But as of 1.0.73, we were Alpaca. It works with Alpaca. And I'm sorry, I didn't get a chance to see your presentation. And Bruce, Bob Denny, I know did it, but I've talked to him at great length, so I kind of have a gist of what it is. But one of the things that I like to use Alpaca for is, and in particular, for example, I have as I mentioned, I have a remote telescope. So bandwidth is always a bit of a concern, and I'm always a little bit concerned about overtaxing that computer. I'll run Alpaca server on that and run a Stellarium locally here on my computer here in Los Angeles, and I will connect via Alpaca, which means that my Stellarium is essentially connected to the telescope in Chile. And I mean, the fact that it's in Chile is not, I mean, I don't want to sort of parade that around. That's not important. It could be in my driveway for all that matters, right? But I can, it's a very planetariums are very resource intensive. Take a lot of graphic time, a lot of graphic speed. And if I can run it here and just communicate, hey, this is the star or the object I want you to go to, or to watch where my mount is going, it's a great use of Alpaca. I think it's a really excellent demonstration of what it could be useful for, even if it's not necessarily on a couple different platforms. So I just want to kind of make that pitch that yes, we absolutely are Alpaca compliant today. It's a great way to use it. I encourage people to think about using planetariums in that way, especially if you have a computer that's maybe, I don't want to say underpowered, but a lot of times we're using a second or third hand laptop or telescope top computer, and it just doesn't have a ton of power, and you don't want to overtax it with the planetarium.
And that's the good thing about the Gemini 2 system is it has the ability to plug in both Ethernet, USB, and God knows what else. And you demoed it with that little yellow box.
Right.
It's your fault that I went out and bought one because I bought one and I found other uses for it, which is actually that little yellow box was a lot better than I thought it was.
It's astonishing, right?
Yeah, for what I paid for it and what it does, it was like, oh, this is really handy. But anyway, I don't want to digress onto that because that's not about that product. So yes, Tanya.
Yes, sir.
What else have you got going on in terms of the product world and what we can and can't do with Losmandy?
Well, nothing new, unfortunately. I'm sorry to say that. As of right now, we don't have anything new. We're just really trying. Our G11Ts are shipping. So if you have a G11T on order, those are out the door. We're shipping them. It will take a couple weeks to get through all of them, though. So this production run is done. There might be a couple left over. So if you want one, call now and get it. There might be a couple. So but that's pretty much it right now. We're still up and running.
Right. And of course, if you guys have an existing G11, regardless of what iteration it is, if you have things that you want to do with the mount, of course, the shop is still open. If you need to do the spring-loaded worm gear upgrade, that can be done. If you have one of the other mounts and you want to convert to a tux motor system, by all means, that is obviously still available. So for you guys who have bought a G11, don't think, look at all these other companies. They've released all these cool new mounts. Now I got to trash a system and buy it. No, you don't have to do any of that. You can bring in your existing G11, and most, if not all, the upgrades can be done to it to get you to have a new mount.
Right, state-of-the-art mount.
Yep. You can get pretty much a brand new mount. I have had customers have their G11, very, very old, like 15 years old, email me and just say, I love the new mount. It is performing amazing. So, I mean, I guess it's worth the money.
Oh, totally. It always has been, always will be. And this is the other thing that I'd love to talk about, Losmandy, when it comes down to mounts. This is not prefabricated stuff that just comes off of an assembly line or is cast molded or whatever the weird cost-effective exercise is. These are precision machined individual items. In other words, there are some poor person sitting in the back, breathing in all this fumes, staring at the blocks being produced. That is his thing. There is so much love and so much care going on at Losmandy that when they produce a mount, it is a good mount, and it's not something that just rolls off an assembly line and some person that probably looks like my mother produced it somewhere.
And I want to add to that. It's entirely made in the United States. I mean, basically, we make it all ourselves. And Scott Losmandy personally assembles every mount. So he's actually going through checking the gear ratios, checking the fitting of everything. I mean, he personally does that, and I don't think that there's another company
There
out
isn't.
there.
Well, maybe
does that
Tech
kind of
Telescopes with Yuri with his telescopes, but
Yeah.
that's about as far as we can throw that one. But I'll tell you now, other than Jeff from Optech, who goes through everything, Scott really does sit there and stares and pokes at every single thing until until he's happy,
Right.
before it can walk out that door.
100% true. And I think that's a bit, he's got over 40 years of experience doing this. So that's the amount of expertise that goes into not only assembling, but tuning that mount.
Yeah. All right. So before we wrap up, if you guys have any last minute questions, now's the time to fire them off. We will be trying to cover as many as possible. If you guys have any other questions, of course, comments are more than welcome. I'm sure Brian and Tanya will get a chance to read them when they look at the chat replay or something like that at some point.
Sure.
I can't think of anything else other than what you've already covered, other than inviting you back to actually dig deeper into some of these things.
Love it.
I think one thing that we definitely got to cover is using PEC. I think that's always been a fear, that people don't really know how to use it. And yes, you're right. If you don't know how to use it, please don't use it, because it'll make things worse. And then you're going to bring back a mount and tell me that the mountain's broken when it really isn't.
Yeah, and not in a mean way. I mean that in the best of ways. Of it's if you don't know how to ride a motorcycle, don't ride it. Not because I don't think that you're not going to look cool, because you're going to crash and die, right? And it's like that for mounts. It's just you'll get a chance to learn more about it, and I would love a chance to do this with you guys live on Woodland Hills Telescope's presentations, and it's really kind of demystifying it. It's really not that hard, but there's a few things you just need to understand.
Oh yeah, and when we get to cover that, I think it'll open up and help you guys to produce better astrophotography at the end of the day. I did see a question waft past earlier in regards to you shooting in an urban environment and the types of filters and things like that. You said you shot LRGB, if I remember correctly.
Right.
What if I'm doing one shot color, or is that really a waste of time?
So I think you're quite, so more generally, because I'm in a situation where there's tons of light pollution, tons of problems with the sky, I know kind of these multi-band filters for one-shot cameras have been coming out. They're anywhere from, I think, duo band to quad band, some other types of stuff. What do I think about those? Do I use them? So there's kind of a two-part answer to that. So first of all, let me be clear. For me, and I think a lot of people would agree, a mono camera with specific either broadband or narrowband filters is almost always going to be a better choice. It's more sensitive, and you don't have to worry about multiple kind of ranges of wavelengths in terms of imaging each part. The other thing about that that not many people kind of fully appreciate is that a monochrome camera with single filters like red, green, and blue allow me to image more efficiently in different parts of the sky. So for example, red is less prone to problems with the atmosphere, and I can image that lower. And then as I go up, then I'll do green, and then at the zenith, I'll do blue, because that's the most sensitive to atmosphere. And in a one-shot color, you just get what you get, right? So I'm not disparaging it, but there's advantages to shooting with monochrome for precisely that purpose. I do have a one-shot color. I have actually about 3 one-shot color cameras. I have been experimenting with sort of these duo band types of filters, like LPass and so forth. I find them to be pretty good, actually. I can still image with a one-shot color camera. I just have to be very thoughtful about the targets. I have to choose very, very bright targets. If I'm choosing darker targets, or not darker, but dimmer targets, they tend to not work so well. And in some of these ones, like I've been trying a quad band filter, and I tried imaging Orion. They kind of are not really accurate in terms of RGB rendering. They will give you an RGB image, but you got to kind of treat them as sort of their own thing. In other words, like, don't expect to get an RGB image out of it. Expect to get a color image that's going to look super cool. Don't get me wrong, but it may not be necessarily color accurate.
I'm probably going to add to this is night glow suppression filters are not miracle filters. All they do is they help suppress certain things. Certain filters have better functions than others. But yeah, don't buy a filter thinking that it's some magical filter where you can set up directly below an LED street light. It just isn't going to do anything. And I explained this recently to somebody where think of light pollution as this. If you have a flashlight in your hands and you shine it across the optical tube, the light pollution filter is going to help with some of that scattering. But if you take the same flashlight and then point it down the tube, there is no amount of filters that can filter that out because the intensity of the light is so much stronger. So as with anything, the further away you get from something, from the point source of light, the lower the intensity. And all a filter really does in this situation is lower the intensity enough to get to that point where you're not getting a pile of fuzz. So in so many ways, don't buy a filter and expect miracles. That's not what they do. That's not what they're for.
Right. So I'm sort of shooting through the equivalent of a dirty window with a bunch of green lights around, right? So the filter is going to help reduce the amount of artificial green light, but I'm still shooting through a dirty window and it's not going to affect that. And I think what a lot of people don't necessarily appreciate, a lot of these filters were designed at a time when sodium vapor lights were the type of lighting in urban environments that was kind of widely deployed, right? They're inexpensive, they're very, very bright, and they have that kind of greenish cast. So there's a notch filter in a lot of these that get rid of this sort of sodium vapor wavelength. But many, many cities are moving to LED lighting, which is a completely different wavelength. So those are starting to become less valuable in terms of notching out that particular light pollution.
And, oh, what's going on
Tanya,
there?
Sorry.
Unmute yourself.
I know. Sorry.
So yeah, and just so you guys are aware, LED lighting in general exists across the entire spectrum. There is no notches that you can knock out. They are almost every part of the entire visible wavelength.
And that is the future. I mean, that's where everyone is going and putting those in urban and suburban environments for sure.
And there's nothing we can do about it. Well, yeah. Anyway, Brian, Tanya, thank you very much for doing this again. I think everybody enjoys it and they love the fact that you guys do all of this, especially when you really drill down into these types of depths of information, because that's basically what people want to hear. So hopefully you guys will be back.
Yeah, I'd love to.
Yeah, we really enjoyed doing this with you guys, with you, Simon. So thank you for having us again and hosting this. It's been great. One last thing before I leave. Thank you for joining today and watching us. Thank you for choosing Losmandy mounts and accessories, but also join our YouTube. That's what was going off in the background because I was sending a YouTube to somebody about the RA extension kit. So join our YouTube channel, subscribe to our newsletter, which is up and running. We're going to be on our third one. So it definitely.
Oh, that's right. I completely forgot. You guys have started to produce a lot of videos on YouTube. I mean, I must have been kicking you guys up the butt so many times about it too, and now you guys are almost there to a certain extent. So, what is your channel so I can link it?
It's
just Losmandy.
Yeah, youtube.com/Losmandy.
Losmandy.
Brian's been really doing a lot of great videos on there. Addition to Scott doing some videos. So Scott does a lot of the mechanical videos, where Brian will do a lot of the Gemini videos. And if you subscribe to it, then you're going to get notifications when we post something new. And if you join our newsletter, you'll also get videos and information that we are, whatever's going on that month. We get one out a month.
Yeah. So I just stuck the link down in the comments. So for those of you who are wondering, that is the Losmandy YouTube. And for those of you who are already existing Losmandy owners, go check out the custom comet tracking video, because obviously it's the most relevant one with the comet.
Wow.
So that's a really good one out there.
Definitely. So thanks again for having us, and call Woodland Hills for your stuff. Thanks, guys. All right.
Thank you very much. All right, guys, we're going to get out of here. So we will be posting information on when the next one is. I will reveal one of the topics. We are going to do CCD versus CMOS, and we are going to go hard into it. So this one's going to be hosted by Richard Wright. I've got a funny feeling we're going to have a lot of people having a big, long battle over this one. So we are going to really get into it and cover it, and hopefully you guys can join in. So until the next time, we will see you again, well, I don't know, a couple of weeks. All right, till then, good night, God bless.